Musik ist leise. So, wir haben ein Problem. Und zwar will ich die AI-Cars machen. Ja, Instant Reload, Instant Reload, okay. Ich habe mich gestern schon ein bisschen rumgespielt. Und ich habe zumindest hingekriegt. Ich weiß noch nicht, vielleicht mache ich sie komplett neu. Na, schauen wir mal. Ich hatte Kontakt zum Entwickler von dem Blazing Rates Template. Der hat mir geholfen, dass mein Level nicht geladen wird. Und ich habe dann noch was gefixt, dass das Menü nicht crasht. Warum ich hier spawne, das verstehe ich auch nicht. So, es geht rein nur. Warum schiebt er da wieder zurück? Aber er fährt schon da lang, wo er soll. Der ist gecrashed, der spawnt gleich neu, okay. Wow! Was ist da los? Komm. Hoppla. Was macht er? Muss da rüber. Irgendwas passt mit ins Plan noch nicht. Mir geht auch auf den Sack, dass das Laden immer so lang dauert. So. Erstens, er steckt einmal da. Warum? Was ist das? Okay. Er bleibt genau da mal stecken. Und er bleibt auch da stecken. Okay, das Ding muss ich noch wohin tun, wo es besser gezählt wird. Und da. Auch das da. So, was kann ich jetzt bei das Plan einstellen? AI Road with 2000. 100. Else by Enable Coordination. Wir brauchen keine Collision, wenn wir keinen Line haben. Was kann man noch ändern? Ich habe da das zurückgesetzt. Wie ist es mit... Da gibt es irgend so ein Distance. Road Spline. So, in-game. Und die Racer AI Distance Increment Gap. Method of driving forward, drive on right. Overtaking. Das war jetzt viel höher. Schalten wir so mal auf 1500. Die Max Speed war auch viel höher. Und das Intervall, das war auf 0. Distance Threshold. Hoppla. So, jetzt muss es eigentlich was verändert haben. Beim Widerstehen. Wir fahren jetzt schneller. Aber ich muss noch einstellen, dass wir das besser bremsen. Und nicht ständig respawnen. Ich stelle mal ein, dass der Offroad besser bremsen kann. Increase collision response. Resetup. So, Brakes, Max Brake, Max Handbrake Torque. Wir stellen das höher. 9000. 6000, 9000. So, das zweite war das Space Card Child. Und das Space Card Child. Wo sind die Wings? So, den machen wir auch ein bisschen stärker. Machen wir es. So, das kann man alles wieder schließen. Habe ich alle Wings stärker gemacht, dass sie stärker bremsen. Warum bremsen sie da? Wie kann ich sagen, dass sie da bremsen sollen? Und nicht so schnell respawnen. Sie sind doch immer zu dumm zu bremsen. So, ich glaube, das hat keinen Sinn. Ich mache jetzt dieses Tutorial da. Das Ergebnis ist das.
My weight, so they won't crash into me as well. So now they also have collision avoidance with me because I'm the same as the AI cars. So yeah, that's pretty good. Now it might have not been a speedy overtake, but some things you can do is something you can do that I think would work really well, and I've tested it previously. But something you can do is that when your car is overtaking, you can add an additional speed boost to the car temporarily. So let's, for example, say for 3 seconds our car has a 10 km per hour boost so that it overtakes speedier. Something I've also done which works really well is going ahead and increasing the distance it looks ahead, because this also generates pretty good overtaking patterns. Because currently when it is overtaking, it overtakes way too steeply or way too aggressively to the side. So something you can do temporarily is
Soll ich das Ganze einrichten?
in this first episode of the Vehicle AI tutorial,
Soweit habe ich mir das schon angeschaut.
AI tutorial series, we will allow our AI vehicle to speed up in straights and slow down in turns. So without further ado, let's get into the video. Okay, so before we get into the throttle code,
Mir scheint, dass das besser funktioniert als das, was ich habe. Also ich werde das jetzt machen. In einem neuen Projekt. Ich werde das jetzt machen. Im neuen Projekt. Was werden wir brauchen? Schauen wir mal.
I kind of want to explain how the throttle code is going to work. The last time we actually, in this first episode of the Vehicle AI tutorial series, non-real video you want is that out of the way, but specific safely of a concept. Just going to say story free controller. I just want to select the normal AI controller. Click to open it. And for this tutorial,
So, wie kriege ich... Ach so, die Strecke da dazu. Ich will diese Strecke haben. So, wir machen Endgame, wir machen Vehicle, wir sagen da All, wir machen da Vehicle AI, Create.
underscore vehicle.
So, was sind da jetzt für Maps drin? Gibt's da Vehicle Basic? Da bin ich. Da Level Offroad, Time Trial. Level Offroad. What kind of level is this? Warum habe ich das nicht? Hat das Tunnel fahren? Wo ist das Spline? Cone Placement. Okay, das ist Cone. Okay. Und wo ist die Road Spline? Das sehe ich doch. So. Landscape Spline Actor. Why are there two of them? Okay. Landscape Spline Actor. Okay, okay. So let's drive. Let's make this tutorial.
We're just going to press enter to save that. We're going to double click to open it up, and then we're going to dock it to the...
So first of all, we make an AI controller. Should I do that with my project? No. So let's try. And we need to add, nope, not this one. AI control. And this is AI racer. Custom.
to the bottom and click on select. We're going to rename this to AIC for AI controller underscore vehicle. AI should be a pretty good name. We're just going to press enter to save that. We're going to double click to open it up, and then we're going to dock it to the main window, and we're going to go to the event graph. Now in this event graph is where we're going to put most of our AI code, but for this tutorial we're not really gonna have a lot of AI code. This is just general setup. Now one of the most important things to set up is inputs. Now a player controller can easily send inputs to the vehicles we are driving. So if I go to my vehicle example map, hit play, then you can see I can drive this car pretty easily. Now the problem is that even though the AI controller is quite similar to the player controller, it doesn't send inputs in the same way. So specifically for the AI controller, we're going to have to make a custom input system, as in we're going to have to call functions on the car related to inputs from the AI controller. Now for that, the easiest thing to do is to use blueprint interfaces, but let's not get ahead of ourselves. Let's try to get the vehicle this AI is currently driving, and then we can talk about the best way to send input to it. So right next to the event begin play, you want to right click in the open and type in pawn. Actually, let's type in get controlled pawn. There's going to be this node called get controlled pawn. You just want to add that, and what this will do is it will take the controller. So if you have an AI or a player controller, it will return the current car it is controlling, and this return value will be the current car the AI is controlling. So we want to drag off this return value and promote it to a variable. We're going to call this variable controlled vehicles should be a good name, and then on begin play we're going to set this value. Now of course, if your race is starting, you probably want to set this value kind of like before the race starts, but for this tutorial just doing begin play will suffice. And now that we have this controlled vehicle, the usual thing you would probably do is drag off this, you know, type in for example vehicle, and then you cast to the vehicle you want to. Now the problem is with casting is that it's very limited, so if I wanted to add more vehicle types, I'd have to cast multiple times. It also gets pretty expensive, so we're going to be using blueprint interfaces because that's the easiest to do, as well as it adds support for more different types of vehicles. So
Ja, verstehe schon.
race a bus,
Blueprint
a car
Interfaces.
on blueprint interface. We're going to call this BPI for blueprint interface underscore what can we call this? We can call this is vehicle. Usually with my blueprint interfaces I like to phrase them as questions, so I'm just gonna save that. Then I'm going to go ahead and double click and open this. Now if you make a blueprint interface, there's automatically a new function created. So this function we're going to go ahead and rename to set throttle. And if you couldn't guess, the idea is that we're going to add functions specifically for setting the throttle, brake and steering of our car.
So, ich will das nicht so nennen. Ich will das BPI. AI Vehicle. Sorry. Then.
The AI can call this and send input to the vehicle. Okay, so now that we have set throttle, we're going to go to top right under my blueprint and click on add new function. We're going to call this set brake, and then finally, now that we have set throttle and set brake, we probably want to have set steering. So just under my blueprint again, we're going to click on add and go to function, and then finally we're going to rename this to set steering. Okay, and let's go ahead and add float values for these, because the idea is that the throttle and brake and the steering is analog, and of course just setting steering you need an input value to do that. So we're going to go to set throttle, then under the inputs, under the details panel at the bottom right, we're going to add a new input. We're going to call this throttle, because the idea is that we're currently updating the throttle code over here, so something like that. Perfect throttle, and we're going to go click on this boolean boolean over here and convert to float, because the throttle, like I said, is an analog value between
Ja,
0
ist
and
klar,
1.
ist
Then
klar.
we're going to go to set break and do about the same thing. We're going to go to the bottom right under details, add a new input. This input's going to be called break. Break, yeah, should be good. And then the float value is correct. We're going to go to set steering, add an input, and we're just going to go ahead and call this steering. Awesome. We can go ahead and compile and save. And if we go to our vehicle AI and I, for example, drag off this get control pawn, I can, for example, do set steering or set throttle, which will in turn send this input to the current car we are controlling. So now with very minimal effort, we can actually make this AI use about the same inputs the player can. Now this isn't fully complete yet because we have a blueprint interface, but we need to add it to the vehicles we want to use. And with
Ist
the
klar,
vehicle template,
Mann.
there's one main interface.
Das kennen wir alles.
And here's
Ja.
the braking controls. Now we want to do about the same, but now with our blueprint interface. So we can top specifically on implemented in full, and now we have added to type in
Wait.
Fs. So now any changes we make here will be made to these other two versions of the car. So let's go ahead and open it up. Now if we open it up, you can see here's the steering and throttle controls.
Hallo,
Here's
Captain Brotzeit, hallo.
the throttle, here's the steering, and here's the braking controls. Now we want to do about...
So, jetzt muss ich ins Fahrzeug. Ich weiß natürlich noch nicht. Also ich mache heute, ich versuche selbstfahrende Fahrzeuge zu machen heute. Und ich schaue mal so eine 5-reihe Tutorial-Reihe an. Ich habe schon selbstfahrende Fahrzeuge. Ich hab ja dieses Blazing Race Template. Und da sind selbstfahrende Fahrzeuge drin, die fahren aber beschissen. Und ich kenne mich so gut wie gar nicht aus. Und jetzt mache ich so eine 6-teilige Tutorial-Reihe durch, damit ich die Basics verstehe. Dann versuche ich meine nochmal anzupassen bzw. neu zu machen.
the same, but now with our blueprint interface. So we're going to just...
Also das Ergebnis ist ziemlich gut. Ja, Stärke. Ich habe gerade angefangen damit. Ja, ich habe gestern schon ein paar... Also ich habe das Blazing Race Template eingerichtet. Ich habe es nicht geschafft, dass es läuft. Dann habe ich einen Entwickler kontaktiert, der hat mir gesagt, ich muss das und das noch einschalten. Dann ist es ständig gecrashed, dann habe ich das Raytracing ausgeschalten und jetzt läuft's. Learning Agents? Meinst du in der neuen Unreal Engine Version, da gibt es so einen Agent, ja. Aber ich habe schon ein Video darüber angeschaut, der kann dir nur Beispiel auf die Quelle geben oder der zeigt dir, wo du die Infos dazu findest. Ja, es gibt es gibt Fahrzeuge mit Machine Learning, ja, aber das funktioniert nicht gut. Also das Ergebnis schaut beschissen aus. Doch, es gibt, glaube ich, Doku dafür. Es gibt auch Anleitungen. Unreal Machine Learning. Ist da drin? Learning Agents, genau da.
Hello everyone, in this tutorial I will
Das Ergebnis ist beschissen. Das schaut aus, als wäre das für Verkehr geeignet. Für ein Verkehrssystem schaut das gut aus.
show
für ein
you how to
Racing
set
game.
up machine learning to train the vehicle to drive along the racing track. Machine learning focus on training algorithms to learn.
Ich habe mir das schon angeschaut, sobald man das niemand zeigen kann, wie das anständig geht. Und ich mache jetzt dieses Tutorial Und ich kann da eh zeigen, wie das
In
Ergebnis
this first
ausschaut.
episode of the video,
Das
going
Ergebnis
ahead
schaut.
and what is it? Increasing the distance it looks ahead because move into that lane. And so now this car has the advantage because it has the inner lane. So you can see it is going good there, but now it's going to, of course, have the disadvantage because of being outer lane.
Und die bremsen auch anständig.
It noticed there was a car in front of it.
Meine Fahrzeuge, die ich habe, die bremsen gar nicht.
And thus want to.
Die bremsen so gut wie gar nicht. Und ich kann jetzt immer kurz. Ich will das kurz zeigen. Also ich benutze jetzt das Blazing Race Template. Da ist alles drin, was ein Auto Racer braucht. Okay. Ja, das neue Rallye-Spiel, glaube ich, meinst du? Das ist auch urschwer. So. Ich bin mittlerweile auch so weit, dass ich meine Map 5-fach gescaled habe und meine Autos in Originalgröße lasse. Ich habe die Autos schon gescaled, aber noch nicht hier importiert. Und ich benutze jetzt das Blazing Race Template. Ich habe hier 2 Fahrzeuge und 2 Spawns. Und wie gesagt, also hier, er bremst hier nicht. Ich habe keine Ahnung, wie ich ihm sagen kann, Vorsicht, du solltest hier bremsen. Das weiß ich nicht. Munitionsgurt. Und was ist das Problem? Das Riggen, das Shrink Wrap. Eine Procedural Animation. Ich verstehe jetzt nicht ganz, warum man eine prozedurale Animation braucht bei einem Waffengurt. Vermutlich, weil es mehrere Waffengurt gibt. Machst du das für Squad oder für was machst du das? So, ich will nicht, dass das so hoch ist. Das, okay. So, das muss auch nicht so heftig. Okay. Funktioniert das mit Bones? Wie ist das geregt? Und hast du da, ich vermute mal, 3 Bones oder 4? Oder pro Patrone ein Bone? Okay, das ist heftig. Und 1, 2, 3, 4 Vertex Groups dazu. Den Füllstand? Das verstehe ich wieder nicht. So. Ich wollte das zeigen, was ich habe. Ich habe jetzt... Ach so, okay. Ah, jetzt macht Sinn. Pro Patrone ein Bone. Okay. Okay. Also meine letzten 3 Tage habe ich damit verbracht, das einzurichten, meine Map zu laden und nur zu erahnen, wie es aufgebaut ist, ein Fahrzeug zu bewegen. Ich habe schon ein bisschen was umgestellt. Ich habe noch keine Ahnung, warum ich hier spawne. The start point is not set. Server reversed. Ja, die UI habe ich nicht gemacht. Die ist vom Blazing Race Template. Da fahren sie mal drüber und dann crashen sie da und... Es ist eh schon viel besser geworden. Ich habe mich eh schon ein bisschen rumgespielt, dass das passt. Wo ist der zweite hin? Der ist, glaube ich, runtergefallen. Die Positionsanzeige passt noch nicht. Jetzt passt sie wieder. Ritter, sind die schon vorbei? Sind die? Da ist einer. Ach, da sind beide. So gut sind die noch nie gefahren, aber schau, hin und wieder bleiben sie stehen. Ich hab Nitro. Schau, dann fahrt er wieder urlangsam. Sie ist eh nicht so schlecht. Die Vehikel-AI. Aber schau dann, die können nicht bremsen. Ich hab ihnen schon stärkere Bremsen gegeben, aber sie bremsen noch immer nicht. Die folgen dem Plan. Die folgen dem Plan. Change color, arrows, assign color, discrete arrow along. Okay, okay. Bind overlaps. Ich habe keine Ahnung, was das macht. Dann. Jo. Das ist Speed Controls. Brakes when in collision. Das war zuerst auf -1 gestellt. Aber wenn ich die auf minus einstelle, die fahren einfach. Ich habe eben keine Ahnung. Es gibt, glaube ich, keinen Nav-Mesh. Es gibt keinen Nav-Mesh, es gibt nur eine Spline. Und diesen Code da. Das ist die Speed Control. Da ist ja noch drin, Plane und Boat ist noch drin. Max Speed Adjustment, Steer and Drive ist da auch noch. Da teleportet er immer, das habe ich schon mal ausgesteckt. Ich habe keine Ahnung über Collision. Ich weiß nicht genau, was du meinst. Welche Collision? Von der Map? Von, von den Fahrzeugen selbst? Das habe ich nicht angegriffen. Das ist alles über Physics Asset von den Fahrzeugen her. Ich habe da eh auch Settings, die nicht wirklich helfen. Das war miserabel eingestellt. Er, er sieht alles als eine Kollision an, glaube ich. Er sieht viel zu viel als eine Kollision. Er bremst ständig. So war es standardmäßig eingestellt. Wo war es? Wo war's? Ich habe da jetzt eingestellt bei Speed Control. Da auf -1. Er soll zurückfahren, wenn er Kollision sieht. Und wenn das so eingestellt ist, pass auf, was die machen. Die fahren mehr zurück als nach vor. Jetzt bleiben sie stehen. Okay. Es ist schon besser geworden. Gestern sind sie noch 30 Meter zurückgefahren. Und da bremsen sie nie. Wo ist der zweite? Das ist schon irgendwie witzig. Da ist er, oder? Bin ich jetzt Zweiter? Warum bremsen die nicht? Ist das zu eng? Wow. Und dann teleporten sie immer. Da ist immer so ein Teleport-Skript drinnen, falls sie stecken bleiben. Wo ist denn der dritte? Ja, ich will ja keinen überkomplizierten Racer haben. Ich will so wie es in den Tutorials die Basics haben, dass er normal fährt, überholen kann und halbwegs eine normale Zeit hinkriegt hier. Und dass es nicht, sich halt nicht verhaltet wie ein Bot. Was ist das bitte? Und warum sagt er mir No Start Point? No Start Point defined. Also so schlimm ist das Thema, glaube ich, nicht. Es gibt, glaube ich, nur die Möglichkeit, vielleicht gibt es noch eine andere, wie man ein Fahrzeug bewegt. Und dann musst du halt anpassen. Ich habe auch angeschaut, es gibt halt einige Fertig-Assets zu kaufen. Die sind aber so schweineteuer. Das teuerste kostet 240 € und dann gibt es noch ein etwas billigeres, das kostet 180 €. Und dann gibt es noch so Simple Racing AI um so 40 €, aber die will ich nicht. So, ich kann ja mal versuchen, das Respawnen ausschalten. Und warum habe ich keinen Startpoint? Das ist definiert als Startpoint. Ist Startpoint. Ist da auch irgendwas mit Start? Startpoint. War der falsch? Ich bin in 5.6. In 5.6. Meinst du hier? Aha. Was heißt das? Heißt das, dass der Boden verkehrt ist? Ah, hier bleiben Sie mal stehen. Genau da ist der Start und dann bleiben Sie hier stehen. Keine Ahnung wieso. Der Boden ist da, der ist nur verkehrt. Und den Boden habe aber nicht ich gemacht. Ich habe jetzt keine Ahnung, wie man die Normals prüft in Unreal. Der Boden ist da, nur so verkehrt. Gut. Wie prüfe ich die Normals von dem Teil? Nein, das sind alles, das ist ein Asset. Das ist das Asset, auf dem ich rumfahre. Und wie kann ich das? Show Simple Collision. Wo ist das nochmal? Dann ist da. Complex Collision habe ich gerne. Wie prüfe ich die Normals von dem Ding? Kann ich? Normals. Die Normals sind okay. Die Normals sind okay. Das Auto hat. Das Auto hat ein Physics Asset. Jedes Auto hat ein Physics Asset. Ja, das geht. Okay, es kann sein, weil genau da bleiben sie stehen, oder? Ja, ich weiß es, ich verstehe eben die ganze KI-Scheiße noch nicht. Eigentlich müsste der Untergrund scheißegal sein, solange er drauf fahren kann. Weil er folgt ja sowieso nur den Splänen. Es kann natürlich irgendwie beeinflusst sein durch den Fußboden, ja. Ja, deswegen mache ich mal die Basics. Ich muss jetzt mal selbst ein Projekt erstellen, damit ich da mal reinfinde. Und wenn ich da ein bisschen Ahnung habe, schaue ich nochmal bei mir drüber und schaue, welchen Fehler finde. Was soll's. Es bringt mir jetzt nichts, da spezifische Fehler zu finden und was zu verändern. Ich will es zuerst mal lernen. Und dazu brauche ich das Video. Wo ist es? Da ist es. So, wir stellen auf die andere Map. Exactly. Was ist hier los? So, jetzt brauche ich ja mein Auto. Was habe ich denn für eins? So, dieses. Ich will aber diese fucking Dinge da nicht haben. Cone. Die Cones müssen weg. Was ist das? Das ist Trackgate. Das ist ja, das sind ja Dinge drin, die ich hätte brauchen können. So, aber egal. So, jetzt müssen wir mein Fahrzeug öffnen. Wo ist es? Das da. So.
To overtake to fix that. And yeah, as you can see, we have
Wir sind
in this
aber.
first episode of the Vehicle AI tutorial series.
Wo waren
This
wir?
for what kind of the AI can
Da.
and let's read the notes on the use turn, send this or simple drag, go ahead and compile and save. And if we go to our vehicle AI and I, for example, drag off the skate control pawn, I can, for example, do set steering or set throttle, which will in turn send this input to the current car we are controlling. So now with very minimal effort, we can actually make this AI use about the same inputs the player can. Now this isn't fully complete yet because we have a blueprint interface, but we need to add it to the vehicles we want to use. And with the vehicle template, there's one main blueprint that handles all the vehicles. So let's go ahead and add that blueprint interface to that. We're going to open up a content browser. We're going to go to content folder, go to vehicles. Actually, don't go to vehicles, go to vehicle template, go to blueprint, and there's going to be this blueprint class. It's going to be called vehicle advanced pawn. Now, this is the parent.
So, wir machen das anders. Wir machen das in der Pawn Base. Genau. Und in der Pawn Base müssen wir API Vehicle, AI Vehicle. Nice.
Blueprint class of the sports car and the off-road car. So any changes so about the to class sizes
Ja, das haben wir.
called when the AI sets the throttle value. Okay, so what we're going to do is
Event set throttle. Okay. Set.
and to just move this a bit closer to the steering and throttle controls. So I'd say somewhere about here in line with the steering and throttle. And now we should do the same thing we do with our player controls, but specifically for the AI. So let's go ahead and look at the player throttle code. And here you can see the only thing that happens is that we set the throttle input of the vehicle movement component. So let's go ahead and select the set throttle input and the vehicle movement component code, press Ctrl C to copy it, and we move to our set throttle event over here and add the code over here. We're going to connect the execution pin and connect the throttle. So that is our throttle code sorted. Now we need to do the steering. To do that, all you do is you go to bottom left under interfaces, right click on set steering, implement event, and now we have a steering event. Let's go ahead and move this closer to our throttle code over here, and all we have to do is copy the steering code we have here. So under this IA steering, all we do is copy the set steering input and vehicle movement components and press Ctrl C to copy, and then we can go to our event set steering, move it over here and just connect this up again. And then finally, we can connect our brake controls. Now this is a bit difficult, or more difficult than usual, but this implementation we're gonna have now isn't going to be too complex. The reason is to make the brake lights work is pretty hard with AI, so there's gonna be a specific video up in this series. It's all
Ja,
about
ich
how to
brauche
make the
keine
brake
Brake
lights work a
Lights,
bit
ist schon
better. Anyway,
okay.
all we really want is the set brake inputs over here. So we want the set brake input and the vehicle movement component. We're going to press Ctrl C to copy that, and then we're going to just paste it over here. I forgot to actually make an event for set brake, so let's go ahead and do that. I'm going to go to the bottom left under interfaces, right click on set brake and implement event. And now it's all the way in the bottom
Ja,
left,
ja, haben wir schon.
and move it over here, the controls. We're just going to double click to comment again, and some way to test this. So go to the bottom left, vehicle AI, and save. We need some way to test this. So if we go to our vehicle AI, and for example on event sec, what we can do is we can go to the bottom left to our variables, drag in the control of the vehicle, and then we can drag off that and do throttle. So you're going to see now this is set throttle message. If we add that, connect the event sec to it, and set the throttle to 1, then if I compile and save, and I go ahead and play, nothing happens. The car doesn't throttle. That's because a player is currently controlling the car. So Unreal Engine knows, oh wow, a player is currently controlling this. The AI should not overtake this or should not override this without the specific instruction to do so. So in that case, you can open up your content browser, go to, for example, sports car, and you can drag in the sports car. Now if I hit play again, you can see still nothing happens. But what's going on here? An AI is taking control of this car.
It's
Because
driving.
player is taking control of this one, and Unreal Engine knows, oh yeah, player is taking control of this one. So yeah, an AI is taking control of this car, but it isn't the AI we made. So if you see in the bottom right, if I click on sports car pawn, and you can see under pawn, there's an auto possess player, auto possess AI, and AI controller class. So here you can see the AI controller class is the AI controller. Now, if I click on this, you're going to see that this is the wrong
Whoa.
AI controller. This is the base class we inherited our AIC from. So if we go to AIC vehicle AI and add that to the AI controller class, if I hit play,
Wow.
you can see now the car throttled. So the code we have here in tick now works. But there's one problem. We had to manually set the vehicle AI specifically for this car, and at the moment we add a new car, so if I add a new one and hit play, only one of them is going to throttle, the other one was just pushed there. But the problem is that the AI isn't taking control of all the cars in the world. You want to go, you want to click on Vehicle Advanced Port, and AI controller AI, try to take over and say new car, because by default, oh yeah, we have set AIC vehicle AI. We're going to delete the set throttle, drag off controlled vehicle, and do set steering. We're going to connect that execution pin, and
Wait, Osama.
we have tested that the throttle works. Let's go ahead and test that the steering works. So we're going to go to the AIC vehicle AI. We're going to delete the set throttle. Drag
Ach
off
so,
controlled
einfach nur
and
testen.
Powerful AI. Full division pin over here. That you can test the braking code of that brake and set the brake to 1. And if I press compile and save, what should happen is the cars can't really move forward, because if we look in our AI control,
Okay. Ja, es funktioniert. Wir machen jetzt weiter bei Tutorial Nummer 2. Aber ich mache jetzt eine kurze Klopause. So, let's go.
The Vehicle AI tutorial series, we will create a path for AI so that it can drive around the track. So without further ado, let's get into the video. Okay, so the first thing we're going to do is make a path for AI. Now the reason for making a path for AI is because without a path for AI, our AI won't know where the
So,
turns
jetzt müssen
are
wir
or the straights are
Pass
of the
for
track.
AI
And so the
machen.
AI can't really drive around the track because it, well, doesn't know how the track looks. So the AI needs a path to guide it around the track. Now the path isn't going to directly control the AI. The AI is still going to have to throttle and brake like a normal player, but it's going to use the path as a guidance to do so. There's a lot of ways to make paths in Unreal Engine, but my preferred is to use a spline. A spline is essentially just a path really, and it has a lot of functions built into Unreal Engine, which makes it really useful because when we want
What
to
is it?
create our
Spline
path, we can
spawn.
just call a few functions built into the spline, and that will just make it really easy to interact with. With that out of the way, let's go ahead and make our path with a spline. To do that, we're going to open up our content browser, and if you're in your content folder, you just want to go to your AI folder. We're going to right click and create a new blueprint class. It's going to be of type actor. We're going to call this pp underscore AI path. We'll open up our content browser, and if you're in your content folder, you just want to go to your AI folder. We're going to right click and create a new blueprint class. It's going to be of type actor. We're going to call this pp underscore AI path. Should be a pretty good name. Going to press enter to save that, and we're going to double click to open it up. And once that's opened up, we're going to go ahead and dock it to the top of the window. Once it's docked, we're going to go ahead and add the spline to this blueprint. Now, a spline is a component inside of Unreal Engine, so to add it, we're going to go to the top left under Components, we're going to click on Add, and we're going to type in Spline. There's going to be two options, Spline Mesh and Spline. We're going to be picking Spline. Spline Mesh is not the one we want, so we're going
Ja,
to just
wissen
leave it on
wir.
Spline. We're going to compile and save because that's really all we need for now. We
Okay.
might open this up later, just a bit later, but for now we're going to close that. Now that it's closed, we're going to go ahead and add our path to our level so we can start building out the path. To do that, we're going
Das
to open up our
Beschissene
content browser.
ist,
We're going to drag the BP path
die
into the level,
Strecke
and
ist
here we
nicht
have our path.
gerade.
Now the first thing I'm going to do is just lift it a bit from the ground. I find that the AI struggles to read the path if it isn't up from the ground. Now that it's up from the ground, we're going to go ahead and work on it. Now, the first thing we want to do is make sure that this path is in the center of the road. Now, this is actually pretty hard to do from a 3D view. So what I like to do, and what I suggest we do, is we go to the top left, and under the save icon, we click on this perspective button, and we change it to top orthographic view. Now, if we zoom out and move our camera, you can see now we have a top-down view of the track with our path over here. Now, the thing is that this is still kind of hard to read because there's so many lines everywhere. So what we're going to do is we're going to go to the top left, right next to the top icon here, and click on wireframe, and change the view mode to lit. And now we can actually see our track top down, and it's really easy to work with. Now, the first thing we're going to do is move the path to the center of the road, and it's not going to line up fully. So something you can do is you can go to the top right, and here at this grid icon, you can click that off. This turns off snapping, which means that you have very fine control of moving stuff in Unreal Engine. We'll turn it on later, but for now we'll use it to line up the path to the center. Now this doesn't really have to be precise. With this path, you can be off by a bit and your AI will still be good. Okay, let's go ahead and build on this spline. Now, how do we build on the spline? What we do is we click on the second point over here. I actually misclicked, but if we click on the second point over
So,
here,
dann
if you hold
noch
Alt on
ein...
your keyboard and drag away, you create a new point. So every time you hold Alt and drag away, you create a new point. Once you've created a point, the moment you click on that point, you'll see these 2 points around it. This is called the tangent of the spline point, and if I click on this point over here and adjust it, I can adjust the curve of the spline at a certain point. So this is how we'll be making turns, we'll be cleaning it up by changing the tangent. But that's really all you need to make this path, so I'm just going to go ahead and undo that. And now what I'm going to do is I'm going to explain how to do the first 3 turns. And I'm probably going to time-lapse the rest.
So, das verstehe ich schon. Jetzt müssen wir mal die Strecke auslegen mit einer Spline. Mit einer Spline. Die muss so sein ungefähr. Und dann mal daher. Okay, das ist so und so. So, was soll es? Soll eine ungefähr sein? Warte mal. Da noch einen, dann da noch einen, dann da noch. So, machen wir wieder Musik an währenddessen. So. Ich will ins Plan, Mann. So, ungefähr. Ja, ja. Mann. Mist. So. Genau. Soll ich das haben? Ungefähr so. Ungefähr so. Warum? Warum ist das schon wieder passiert? So, das ist der bekackte Tunnel. Ich habe keine Ahnung, wie wir den machen sollen. Ungefähr so. So, jetzt müssen wir nur noch die Höhe anpassen. So, wir brauchen eigentlich nur... Kann ich das irgendwie... Snap? Hallo Ramino. Hallo. Ja, immer wieder gerne. Heute mache ich KI-Fahrzeuge. Ich versuche gerade eine Spline entlang der Strecke zu legen. Und ich lerne gerade, wie man Fahrzeuge selbst fahren lässt. Das ist der Weg. Es ist... So, runter damit. So. Was ist. Achso, das ist der Tunnel. So, das machen wir einfach runter da. Es gibt sicher eine schönere Lösung dafür. So. Jetzt haben wir da. Da. Entlang der Strecke. Da können wir ein bisschen runter. Was ist da schon wieder passiert, Mann? So, ist auch egal. Es soll ja einfach nur den Streckenverlauf folgen. So,
We'll cut it based on trees. Let's go ahead. Put the
so jetzt zeigt er uns, wie er das Plans macht. Das haben wir gerade.
big position of getting egg point. It lines up problems and go.
Ja.
Now, that is the one a bit maple. Okay, and now I've fully built out the path for the AI, but now we have a problem here. So here's my ending point, and here is the start of the spline. Now the problem is that it isn't connected. So the moment the AI wants to go around the track, it can kind of get a bit buggy because, well, it doesn't know it's a full loop or full closed track. So how do we fix this? Well, once you have the BP AI selected, the BP AI path, then under the details panel, you want to click on the spline component and click on closed loop. And now we have a fully closed track overall. Now what we're going to do is we're going to go to top left and change from top to perspective view. And this is my fully completed track. It's not 100% perfect, but it will definitely suffice for this tutorial. And yeah, I think it's going to be pretty good. Now, the next step is actually getting our AI to follow this path. Now, I have recorded this tutorial quite a few times and I just stumbled across my words and it was really hard to explain this. So what I did is I got an image to kind of explain this or explain what we want to do. Now, what we want to do is we want to find out where our AI car is. Then we want this AI car to look for the closest part of the path closest to it. So let's say we want a point over here. This is pretty close to the AI car. And let's say, well, what we also want to do is we want to get the front angle of the car, so the angle it is facing. Then we want to
So,
find
sehr
the
schön.
angle to the path, and based on that angle, we want to give it steering input. So that if this is a bigger value, we want to do
Nein.
bigger steering. If it's a smaller angle, we want to do little steering. If the car was on the opposite side, we'll do opposite steering, so we'll turn left. And that's the general idea. We want to get the AI's location. We want to get the AI's location and find the closest point on the path to it. Now, you kind of
So,
saw
Musik
I
mache ich
made
wieder
a
aus.
random point, and I'll explain that later. But
So, jetzt hat
yeah, we
er
want
kurz
to find the
erklärt,
closest point
wie
on
er
this AI
den Weg
path to the path.
berechnet.
Car is on the path for the AI. So let's go ahead and create the function that our AI will call to find the location of where it needs to drive to. So to do this, we're going to go to our content browser. We're going to go to our BP AI path, because this is where the code is going to be. And actually,
So.
I think we're going to create a blueprint interface, because we're going to be calling this function a lot. So we're going to open up our content browser. We're going to right click. We're going to go to blueprint. We're going to go to blueprint interface.
Wir
We're going
bauen
to
noch
call
eins.
this BPI underscore is AI path. So anything that is an AI path should have this
What is AI path? Okay. Let's make a blueprint interface. Blueprint interface AI is path. Is AI path. AI path. Okay.
blueprint interface. We're going to go ahead and double click to open it up. I'm not going to dock it or anything. And what are we going to call this function? We're going to call this function get closest location to spline. So this is the, actually I think to AI path is a bit more fitting. So it will get the closest location to the AI path. So this is the closest point on the AI path to the car. And we're going to just press enter to save that. Now, of course, to get the closest point from our car to the AI path, we actually need to know the location of our AI car. So we're going to add a new input under the details panel. We're going to set the type to vector, because that's like a location storage. We're going to set this to, or call it AI location. So this is the location of our AI. And if we want to get the closest location on that AI path, it also needs to return a location. So we're going to add an output, and it is of type vector, so that's correct. But we're going to call this location to steer to. So this is the location we want to primarily
Location to
drive
was?
to.
Location to? What?
Steer to. So this is the location.
Location
we
to
want
steer to.
primarily-
Okay. Location to steer to. Okay.
drive to. We're going to compile and save, and we're not going to need this anymore. We're going to close that. And now we have to add that blueprint interface to our AI path. So what we're going to do is we're going to go to the top, go to class settings, go to the bottom right under interfaces, and click on add under implemented.
Blueprint AI Path. Okay, und da müssen wir jetzt da. Das neue Interface. Is AI Path.
Interfaces. We're going to go ahead and type in BPI underscore AI path. And now that we have that, if we go to the bottom left under my blueprint, under interfaces, we should now see our custom function. Let's go ahead and double click to open that. And this is now where we're going to put the code.
Oha.
The first thing I'm going to do is
Stürmt
move
es.
the return node a bit away, because we want space for the code. Now, how do we get the closest location to the spline from this? Well, what we can do is we can actually drag off this AI location. We can do get distance, so get distance, Then you're going to find this get distance along spline at spline location with spline in the bracket. Now, if you click on that, now we have this. And what it will do is this will tell us how far along the spline we are based on the location of our car. Now, of course, this is not an actual valid location. So how do we get the actual valid location from this? Well, we'll drag off the return value and do a get location. And there's going to be this option, get location at distance along spline. You want to select the one with spline in the brackets, or whatever you name the spline fin, that's going to be in brackets. But you just want to select the get location at distance along spline. And now this is fully set up. This is the location closest to the AI car on the spline. We're going to connect that to the location to steer to. And one final thing, the coordinate space. So with this, we want world position coordinates. So what we're going to do is we're going to click on local, change it to world, change this from local to world. So both of these, make sure they're set to world coordinate space. I might clean up this code a bit later because there's actually a small
Okay.
thing I want to fix here
Haben wir.
later in the video. So, but this should be good for now. We're going to compile and save. Now that that is compiled and saved, we need some way to call this in our AI car. So to do that, we're going to open up our concept browser. We're going to open up our AIC vehicle AI. We're going to delete all the set steering, set throttle, set brake code that's not needed anymore. And now we need some way to get that path in the level. For this, I'm going to use a get actor of class node. So here on begin play, I'm going to drag off the set node and do get actor of class. So now that we have that, I'm going to click on actor class to select our class. We're going to make this the BP underscore AI, and as this AI path, we're going to select that. And now this return value is the AI path. Now if we drag off this return value and promote it to a variable, this is now the AI path. So I'm going to name it AI path. So anything we want to do path related, we use this variable. So now we have our AI path sorted. Now we need some way to, use the information from the AI path. So now in this section, we're going to go ahead and actually make the car steer to that location. So for that, we're going to create a new function. So on the bottom left, we're going to add a new function under my blueprint. And this function, we're going to call calculate steering. So this entire function's point is to calculate how much steering we should do. Now that we have that out of the way, let's go ahead and, actually create the steering code. So the first thing we have to do is get the location closest to our AI car from that function we created. So in the bottom left under variables, we're going to drag in our AI path, get AI path, drag off that, and get location closest to AI path. You can use the normal one or message. I just remembered that
Get
because
closest
we used the get
location
of class
to
node,
AI path. Get
it
closest location
wasn't
to.
necessary really to create the BPI in this case specifically. But I'm just going to use the message one in this case. Anyway, I'm gonna drag off the calculate steering.
But,
And connect that.
wait a minute.
That's
Warum habe ich da nichts? AI path, BPI ist AI path. Get closest. Line. So AI path. That's it. Das ist dasselbe, oder? To spline to AI path. Das ist. Ich sage das BPI AI path. Aber er hat eine Message. Get closest location. So war das. So hat das.
Get closest location to AI path. Now here we have to actually feed our AI location or the location of our AI car So in the bottom left, we're going to drag in our controlled vehicle variable, use a get, drag off that, and use a get actor location. Now we have that location, we can feed that into the AI location. And we can just kind of sort this a bit. So something like this should be fine. I'm just going to select this code over here and comment it. So select all 3 of these nodes, or all 4 of these nodes. We're going to press C on our keyboard to comment that, and this I'm going to call. So this is that. We're going to now there's going to be this find look at a rotation. You want to use that node, and
What
the
is
start should
this?
be the.
I can't read it. Find look at rotation. Find and rotator.
The location of your car, and the target is the place you want to steer to. So we're going to connect the location to steer to the target, and connect the get actor location to the start. And now we have a find look at rotation. So this is a rotator, but it's still not enough. We need to use a delta rotator, because we need to also find the angle between the car and this angle. So we're going to rotator. So that's in the A value, and in the.
Okay, machen wir weiter. Wo sind wir? Da sind wir. Delta rotator.
B value, we should get our actor's rotation. So we're going to go to the bottom left, drag in our controlled vehicle,
Control vehicle.
and use a getter. I'm going to drag off that and do get actor rotation. We're going to drag that to the B value over there, and that should be good. Now this final value over here is the angle from which we are from the path we want to drive to. Now if I right click this and split it, then we have these three values. There's a roll, pitch, and yaw. In our case, yaw is the left and right rotation of the car, so this is the one we want to read information from. Now, the problem is with this, right, is this is an angle. This is an angle from the car to the AI path. How do we use this for, or how do we convert this to steering input? Well, there's a few ways, but I like to use a map range node. So if we drag off this yaw value and type in map range, there's going to be 2 options, clamped and unclamped. I'm going to use clamped over here. And the idea is that based on how much of an angle this is, it will convert that big value into a smaller value. So in this case, steering goes from -1 to 1. So the outrange A we're going to set to -1, and the outrange B to 1. So that is the steering ranges set up. Now you might think, okay, so we're going to make this one -180, or make this one 180, because you know that's how angles work. You can go heavily to the left or heavily to the right. But you'll be wrong, because if you set this to, let's say, -90, so -90 angle, we go full speed to the left. The problem is with that, right, is that we don't want the car to start going full left when it is already having to make a big turn. We want the car to have to full turn very early so that it can actually turn in. If we set this value too high, the car is going to turn in way too slowly, and it's just going to cause a lot of problems.
Yeah,
So
yeah.
for this, I actually make it -10 and set the B range to 10. So the idea is that if an angle is bigger than -10, we should give full left control. If it is smaller than that, we'll scale it down a bit. So for small angle adjustments, the car isn't going to turn heavily, but for the big turns, it's going to go full out and turn correctly. Now this return value over here is our steering input, and now we actually have to feed that to the AI. Now in this case, I'd like to do that on the event graph. So what I'm going to do is I'm going to go to the calculate steering function. I'm going to add an output.
Calculate steering function. Wo habe ich den? Calculate steering. Wo ist die drin? Da.
I'm going to go to the calculate steering function. I'm going to add an output. It's going to be of type float. So this is our steering input. I'm also going to call this steering input. Yeah, that's good enough. I'm going to move this return node to about here and connect the map range clamp to that. And finally connect the return node to the get closest location of AI path. So I'm going to select this bit of code here, so the find, look at, rotation, and delta rotator, but not the map range clamp. I'm going to select that and comment this. I'm going to call this get the angle to steer to base, actually get the angle to steer to. So this is the angle, actually get the angle of steering should be good enough. Get the angle of steering and go ahead and select this one and call it, what are we going to call this? I think convert angle into steering input should be good enough. I'm going to move this return node out a bit, move this comment block over here, move this one over here. I'm going to add a small reroute over there. And yeah, this should be good enough. I think this is pretty well sorted and explains everything we need. Maybe just, yeah. Okay, that's perfect. We're going to go ahead and compile and save. We're going to go back to our event graph. What we're going to do is we're going to go to the bottom left under functions and drag in our
AI. Into the event graph. Calculate steering.
calculate steering. Then we're going to go ahead and drag the event tick to that. And this is now the calculate steering. We're going to drag off that and actually do the steering input. So to do that, we're going to go to the bottom left under variables and drag in our controlled vehicle and get that. I'm going to drag off that and do a set steering, which is that BPI we set up in the first episode. Going to click on that, and now we can set the steering. I'm going to connect the steering input and plug the execution pin in. Just going to just going to go ahead and line that up. Yeah, that's good enough. Okay, and now we need to add a bit of throttle because you know the car needs to at least go a bit forward for us to be able to see the steering. So what I'm going to do is I'm going to go to the bottom left, drag in a controlled vehicle again, use a get, drag off that, and do a set throttle. So a set throttle message. And I'm going to set this value to something small like 0.2, because currently with the settings, our car isn't actually going to do too good of a turn at a high speed. The idea is that in the next tutorial where we do the throttle code, we're going to explain how to improve the steering code to work with this
So,
new
schauen wir uns
higher
das mal
speed
an.
overall. But for now, we're just going to use 0.2 throttle, move that up, and now let's go ahead and compile and save. And now if we hit play, we can see our AI car starts to turn in the path, so it's doing it really slowly. Let's see if it will do it correctly. Is he doing it? Oh, wait, is he turning the wrong way? Actually, I think he is. And that kind of does make sense for some reason. Let me just test this. I'm just going to move it to the front because I kind of think I know what this is. Let's see if it is what I think it is. Else it might have been just
Okay,
like
es
this
fährt.
overall. Is he turning right? Okay, yeah, it is what I think it is.
Es macht
Now,
dasselbe wie Sense.
remember when in this image I specifically drew a random point, right? the closest point to the car would be this, because it takes the center location of a car and gets the closest point. But there's one big problem with that. If we check the front angle of the car and check the side angle, you'll see it is 180, which means that the game is telling the AI to go full speed to the right, which is wrong. But the moment that the AI gets in line with this road, it's going to do the same again because it's checking the closest point. We need to add a bit of offset so that instead of checking the closest point around
Okay, ja, ich verstehe
I
schon.
set it up this way along spin value, and you should follow along for this. We type
Jetzt, genau. Nein.
in plus or add operator, and we add that. Now we can add a bit more distance for AI so that it can actually take turns better. So let's make this value 500. Let's say the AI car needs to look 500 ahead. I'm going to plug that into distance. Let's compile and save, and let's see what happens now. Let's see if it works better. And now you can see it's actually turning the right direction, because previously he was actually driving the reverse of the track. So let me just press F8 to go out of my current control of my car.
He steers to the wrong direction. Was läuft da falsch? 10, minus 10, 1, minus 1. Calculate steering. Sicher, dass das ist. Okay. Jetzt schaut das schon besser aus. Jetzt scheint er dahin zu lenken. Nope. Ich kapiere das nicht. Es wird nicht besser.
You can see he's driving in the right direction. If it or ag off the
Stimmt ja nicht. Ja, das stimmt.
for some reason. Is he doing it? Oh, wait, is he turning the wrong way? Actually, I think he is. And that kind of does make sense for some reason. Let me just test this. I'm just going to move it to the front because I kind of think I know what this is. Let's see if it is what I think it is. Else it might have been just like a fluke oval. Is he turning right? Okay, yeah, it is what I think it is. Now, remember when in this image I specifically drew a random point, right? The closest point to the car would be this, because it takes the center location of a car and gets the closest point. But there's one big problem with that. If we check the front angle of the car and check the side angle, you'll see it is 180, which means that the game is telling the AI to go full speed to the right, which is wrong. But the moment that the AI gets in line with this road, it's going to do the
So,
same
das ist
again
wild, das
because
ist
it's
wild.
checking the closest point. We need to add a bit of offset so that instead of
Vielleicht
checking the
ist es
closest
auch
point, we check
verkehrt.
a point further. Imagine it kind of like this. When you're going around the turn in a real life, you don't look right next to you while you're taking the turn. No, you're looking ahead to make the turn. Our AI needs to see ahead to know how the turn is going to look. It can't look next to it because it's going to turn way too aggressively trying to match this. So what
Es
we're
geht
going to do
gar
is we're going
nichts.
to add a bit of offset.
Ich hab
Point. We need to add off that and do get axis rotation. We're going to
the closest point to the spline. Get closest location to AI path. Da habe ich was anderes. So, schauen wir noch mal kurz. To AI path hat das genannt. Deswegen ist es rename AI path. Gut. Das haben wir alles. Get Actor Location. Location to steer. Find, look at rotation. Z. Z. Z is the green one. This means he should drive this way. Right? The AI path. Between us and next is don't know. Ich weiß nicht, was ich falsch mache. Ich habe es genauso gemacht wie er.
we'll call it AI. Look, we want AI and this turn value and add the whatever you name the spline to see it on later in the video. So, but this should be good for now. We're going to compile and save. Now that that is compiled and saved, we need some way to call this in our AI car. So to do that, we're going to
Das
open
geht
up
gar
our
nicht.
browser. We're going to open up our AIC vehicle AI. we're going to delete all the set steering, set throttle, set brake code that's not needed anymore. And now we need some way to get that path in the level. For this, I'm going to use a get.
Summers.
This return value, this is to have us call the point we have to do, and we created. So in the bottom left under variables, we're going to drag in our AI path, get AI path, drag off that, and get location. I just remembered that because we used the get actor of class node, it wasn't necessary really to create the BPI in this case specifically, but I'm just going to use the message one in this case. Anyway, I'm gonna drag off the calculate steering and connect that to the get closest location to AI path. Now here we have to actually feed our AI location or the location of our AI car. So in the bottom left, we're going to drag in our controlled vehicle variable, use a get, drag off that, and use a get actor location. Now we have that location, we can feed that into the AI location. And we can just kind of sort this a bit. So something like this should be fine. I'm just going to select this code over here and comment it. So select all 3 of these nodes, or all 4 of these nodes. We're going to press C on our keyboard to comment that.
Macht er
This I'm going to
irgendwas?
call get the closest point to the spline. So this is the closest point to the spline. And now this location to steer to. We need to do something with that.
Das macht mich fertig. Das macht mich fertig. Ich bin kurz zum Klo. Eigentlich kann ich das Auto dann so lassen und den AI-Controller verwenden. So, ich scheiß auf das Level. Das geht mal am Senkel. So. Racinggame Spline. On Spline. Spline Mesh. Wie ist das gemacht? Wie ist das gemacht? So. Escape Spline Actor. Was ist er? Landscape. Okay. Wie kann ich da eine scheiß Road machen? Okay. Scheiß auf das. So, wir machen da einfach wieder ein AI Pass. Wo ist Close? Closed Loop. So, jetzt haben wir da einen Start. Wir haben da ein Fahrzeug mit einem Racer Custom. Es fährt einfach davon. Tschüss. Ciao. Weg ist er. Warum fährst du hier nicht? Junge. Ich hab's genauso gemacht.
So how to get active. So this is a rotator. Start. Steer to.
So,
And you want to use that look at. Now there's going to be this find look at a rotation. You want to use that node.
fine.
And the start should be the location of your car. You want to use that node.
So, kurze Pause. So, weiter geht's. Weiter geht's. Mizikazi sitzt vor dem Monitor. Sehe ich nix. So, Mizi. So, ich sehe meinen Pauseknopf nicht, Mizi. So. Warum fährt ein verschissenes Fahrzeug nicht entlang von meinem AI-Pass? Das musst du mal begreifen. Was habe ich falsch gemacht?
Percent perfect, but it will definitely suffice for this tutorial. And yeah, I think it's going to be pretty good. Now, the next step is actually getting our AI to follow this path. Now, I have recorded this tutorial quite a few times and I just stumbled across my words and it was really hard to explain this. So what I did is I got an image to right click. We're going to go to blueprint. We're going to go to blueprint interface.
Ja, das haben wir gemacht.
Close
Das
on
ist
the AI path to the car and panel. We're going to set the type to vector because that's like a location story.
so.
Okay,
Das
so
machen wir jetzt auf. Aber ist AI-Path? Den haben wir noch nirgends eingebaut. Moment, deswegen geht's nicht.
We'll call it AI location. Needs to see ahead.
Wo haben wir den
To
erstellt?
do too good of a turn event tick to that. Smaller than
Ist AI-Path.
so in the bottom of the road, it's going driving along here. There's no collision avoidance or anything.
Wo kommt der
Going
ist
to roll
AI-Path?
And this function we're going to call with this we want world position coordinates.
Warum haben wir das ist AI-Path? Get closest? Okay, nein, wir haben es eh hier. Okay.
So what we're going to do is we're going to click on local, change it to world. But this should
Das haben wir, ja.
now we need some way to get
Ja, das haben wir auch.
Now if we drag on, use this.
Das haben wir
So for that,
auch.
steering. Create the steer on a drag location or mess. Now here we have to actually
Get
feed
close
our
location to
location
AI
or the location of
path.
our AI car. So in the bottom left, we're going to drag in our controlled vehicle variable, use a get, drag off that, and use a get actor location. Now we have that location, we can feed that into the AI location. And we can just kind of sort this a bit. So something like this should be fine. I'm just going to select this code over here and comment it. So select all.
Ich verstehe nicht ganz. Warum folgst du meinem Splanpan nicht? Ich will einfach abhauen. Warum? Du sollst doch meinen verschissenen Spline-Path folgen. Warum macht er das nicht?
All three of these nodes, or all four, some steering. Well, what we're going to do is we're going to drag off this location to a rotate steer to the target.
Find look at rotation. Habe ich da das Richtige?
Location to steer station. You want to look at
Rotator math. Find
this game-
look at rotation. Find look at rotation. Das genau das habe ich. Was dann?
going to be this find look at a rotation. You want to use that node and this
Ja, das haben wir
location
gemacht.
to the start.
Moment. Da ist der Fehler. Da ist er. Fick ja. Und jetzt mach was. Es geht. Geht. Nice. Er bremst nicht. Er lenkt links. Doch. Oha. Ähm, ich will die Splines sehen. Wie kann ich die sehen? Ähm, wie kann ich die sehen? Add Spline Mesh. Äh, irgendwas. Okay. Das geht so nicht. Wir haben da eine Spline. Wir legen einfach was anderes aus. Wir machen. Wir machen entlang. Hier eine Strecke, dass man es sieht. Wo ist meine Maus hin, Mann? Damit ich sehen kann, was er tut. Okay. So, fährt er da? Wo soll? Oha. Fast, ja. Er ist zu schnell, aber es geht. Es geht. Ähm, Gehen wir nochmal zurück zum anderen Level. Time Trial war das, glaube ich, oder? Und wenn ich jetzt... Er dreht um. Oha. Jetzt ist aber zu schnell, glaube ich, oder? Jetzt schmeißt ihn raus. Doch nicht. Doch nicht. Wo ist er? Oha. Der ist schon gar nicht so langsam. Oha. Kommt gar nicht hinterher. Oha, der fährt schon besser als der im Blazing Race Template. Oha, sehr schön.
Now,
So, das
on
heißt,
my blueprint
haben wir das alles? Wo waren wir stehen geblieben?
currently, no big problems here.
So, ja, da hat er das noch reingemacht. Das haben wir
Take a
auch.
look, see what turning the right is of the map and go about 50 miles per hour in Unreal Engine. Now that is pretty slow. We'll talk about in the next episode of how to make it turn faster or how to make it go faster around the track. But for now, this tutorial is just focusing on the turning. But you can see now, he's really taking the turns well, following that pretty well. He's following that well. Going up.
So, es geht alles. Er fährt nur ein bisschen zu schnell. Das haben wir ja irgendwo. Wo haben wir das definiert? Da. So, stellen wir ihn richtig hin. Und wenn ich sage Simulate. Oha. Oha, oha. Zu schnell, zu schnell. Aber kein Problem. Ach so. So, jetzt machen wir weiter bei Tutorial Nummer 3, oder? Nice. Kann ich jetzt schon ein zweites Fahrzeug hinsetzen? Das muss ja eigentlich auch gehen. Wenn ich ein zweites hinsetze. Und er kriegt auch den Controller. Das war so ein bisschen weiter vorne. Und jetzt will ich noch sehen, ob einer schneller ist. So für die... Was ist jetzt passiert? Was soll das? Was Science? Bitte. Habe ich noch nicht. Habe ich noch nicht. Aber ich habe da keine großen Schwierigkeiten, denke ich. Ich brauche nur verschiedene RC-Car-Sounds. Ich brauche keine echten Fahrzeugsounds. Es gibt ein Unreal Pack. Es gibt ein Unreal Pack mit fertigen Sounds. Das kostet 30 Euro oder so. Ich habe auch schon gesucht. Man findet auch so. Ja, ich habe... Ja. Es ist schwierig, echte Fahrzeugsounds zu machen, ich weiß. Ich weiß. Also ich weiß ungefähr, wie man es einrichtet. Unsere Waffen in Kickstarter-Brücke packen. Moment. Okay, also der war Profi im Sound erstellen für Waffen. Verstehe nicht ganz. Aber soweit ich verstehe, ist der Typ Profi gewesen im Sounds machen für Waffen. Okay. Ja, was ich über Sounds machen auch noch weiß, ich habe den Bohemia Interactive Channel abonniert auf Instagram. Die zeigen manchmal Videos, wie sie auf so Schießplätze fahren und die Waffen aufnehmen für Armory Forger. Oder, oha, der ist sogar schneller. Eingeholt. Ja. Es gibt glaube ich, einmal im Jahr so einen Tag der offenen Tür. Und die sind ja in Tschechien. Ich habe schon überlegt, mal hinzufahren. Ja, man sieht halt auch so Bilder, wo sie im Panzer rumsitzen oder Motion Capture aufnehmen. Okay, cool. Bist nicht reingegangen, weil zu war oder kann man überhaupt reingehen? Ich weiß nicht. Kann man einfach so in ein Game-Studio reinspazieren und Hallo sagen? Ja, ist nicht weit weg. Ja, ich weiß. Okay, Sonntag. Ja, versuchen würde ich, wenn ich schon davor stehe. Jetzt hat er wieder was verloren. Die fahren schon ziemlich. Das ist sehr gut simuliert, finde ich. Er haltet sich nur an der Linie fest. Ja, ich bin auch überrascht, wie gut das läuft. Aber er kann auch nicht bremsen. Und noch nicht überholen. Und jetzt wollte ich sehen, ob einer schneller ist von den beiden. So, aber egal. Ich mache jetzt Tutorial Nummer 3. Was machen wir da? Ich kann ganz normal fahren. Ich spawne hier. Beim Player Start. Wo ist er? Da ist er, glaube ich. Oder nein? Wo ist er? Irgendwo ist er Player Start. Da spawne ich. Und die haben ausgewählt Man Racer hier. Die AI-Controller. Und wenn ich spawn, ich kann ganz normal spawnen und processen. So, was steht jetzt an? Jetzt steht an Making our AI throttle and brake. Jetzt machen wir die Bremsen. Und es dauert 27 Minuten. Das ist sehr lange. Er erklärt das detailliert. Ich kenne die ganzen Funktionen.
AI tutorial series, we will allow our AI vehicle to speed up in straights and slow down in turns. So without further ado, let's get into the video. Okay, so before we get into the throttle code,
so, er macht die Musik wieder aus, die stört. Und er ist so leise, ich weiß nicht.
I kind of want to explain how the throttle code is going to work. The last time
ja, er fährt strikt auf das Spline. Und das macht er sehr gut. Ich bin am Überlegen, ob es gut wäre, gleich mit der Spline eine Ideallinie zu ziehen, wo die AI fahren soll. Das wird schon. Ich weiß nicht, ob das geht. Aber bei meinem Spiel brauche ich nicht unbedingt eine Ideallinie. Es ist. Mal schauen. Aber mich würde es
we
interessieren.
actually took an image of the car going around a turn, and I explained how the turning code was gonna work. Now this time I'm going to do something similar for the throttle code, so let me just go ahead and open up this image. Now last time when we did the turning code, what we did is we took the angle of the car, so the angle it was facing, and then we took a point further ahead from the car along the spline, and then we determined the angle between these, so the difference in angle between these two angles. Now, the reason why we took a point a bit further ahead from the car is because in real life you look ahead of your windshield to determine how you should turn, and this was similar to that. If we put it too close, the AI would just turn rapidly for no reason. So we had to add a bit of distance to smooth that out. Now, the throttle code is actually very similar to this, except instead of being sampled so close, or the point we're using being so close, we actually take a very far along point. So let's say about here. Now the reason for this is because when you want to throttle or you want to find out the top speed you should be going, you want to know as much of the track as possible. And so if we were to sample a smaller point, let's say here for example, the problem is that the car would think, oh wow, this is just a really small turn. I can go top speed and there's going to be no problems. And then it just crashes over there. And that's bad. So what we do is we sample a further along point so that the car knows, oh, this is a turn that's going to be a bit harder, so maybe I should slow down. And that's how that's going to work. So all we do is once we have our further sampled point, we just go ahead and determine the angle between the front of our car and this point over here. And then once we have the angle, this isn't actually going to control the throttle. No, this is going to determine the top speed of the car. So the bigger this angle is, that means, oh, this turn is wider or this turn is a
Okay, jetzt entscheiden wir über die
down. The smaller this angle is,
Autogeschwindigkeit.
this is straight, I can actually go top speed over here. And that's how the throttle code is going to work. We're going to determine the top speed the car should be going, take the top speed from our car, the speed it's currently going right now,
Ich
and then we
verstehe
just
schon,
make
ja.
sure we throttle and brake as needed to reach our speed milestone or the speed we need to reach. Now with that out of the way, we can go ahead and go code all this throttle code. Now the benefits of this system is that it's very similar to the turning code, so it's going to be really easy to change our turning code to work with throttle. Now with that out of the way, let's go ahead and actually code. We're going to alt-tab into Unreal Engine. Of course, you're just in Unreal Engine. And what we're going to do is we're going to open up our content browser. Then if you're in your content folder, you want to go to your AI folder and you want to open up the BP AI path. Now you're going to be probably in the event graph, so all we want to do is we want to open up the get closest location to AI path interface over here. And last time we actually made this bit of code here. So we added the additional distance we did over here with this
Ja,
graph.
ja, haben
Now the
wir.
problem is that with the throttle code having to require a bit more distance than the turning code, we're going to have to make this an input to our get closest location to AI path to make sure we can easily reuse this code without having to make separate versions for each car and that. So we just want to make this code as versatile as possible. To do that, we're going to have to change our get closest location to AI path in our blueprint interface. So let's go ahead and open up our content browser and go to the BPI underscore is AI path. We're going to open it up. And here we have the get closest location to AI path.
Okay, da hätten wir noch einen Input.
And then once we click on this function here in the top right on the get closest location to AI path, we're going to go to inputs, add new input. We're going to change the type from Boolean to float because that is how the distance is stored. We're going to just change.
So, machen wir das gleich, So, wir sind da im BPI Path. Wir brauchen meine Blueprints. Wir brauchen dann noch einen Input. Er hat gesagt, das ist ein Float, oder?
This new param to additional distance should be a good name. And the reason for calling it additional distance is because we're adding more distance to the AI path point we're sampling. So let's go ahead and compile and save. We're going to close the BP underscore is AI path. And now that we have this additional distance, all we can do is we can right click here in the open. We can type in additional distance and just drag in this value. And it will take this input over here and plug it into here. This is just a neater way to do that. And now we have our additional distance code. Let's go ahead and compile and save. Close that down. We shouldn't need anything with that for now.
Okay, one moment.
A way to do that. And now we have and plug and here in the open. we can type in additional distance and just drag in this value, and it will take this input over here and plug it into here. This is just a neater way to do that. And now we have our additional distance code. Let's go ahead and compile and save, close that down. We shouldn't need anything with that for now. And let's go to our AI code itself. To do that, we're going to open up a content browser. I'm going to open up the AIC vehicle AI. And now you can see we're in the calculate steering function. So if you're not in the calculate steering function, just go ahead and double click to open it up. But now that we're here, we can see, oh, our additional distance input is over here and it's set to 0 by default. For now, let's go ahead and set this to 500 like it was in our preview. We're going to change this value out a bit later to smooth out the turning and throttling, but for now, let's just get the throttle code up and running. So what we're going to do is we're going to go to our event graph, close the calculate steering function. And what I'm going to do is I'm going to go to the bottom left under functions, right click the calculate steering, and go ahead and duplicate it. The reason for this is that the calculate steering function should be very similar to the calculate throttle function. So I'm just going to copy and paste it and make our lives way easier. Now we're just going to go ahead and rename this calculate steering to calculate, what should it be? Throttle. Calculate throttle / brake. I recommend using a lowercase b because if you use a uppercase b, it might mess around with formatting and stuff, and it might be a bit harder to read. But now we have our calculate throttle and brake code. To get closest location to AI path, what we're going to do is we're just going to make this value about 3 times the one we use for the turning code. So in this case, it would be 1500. And now this should be good. This map range clamp node, on the other hand, we're going to have to change.
Okay, one moment. Wir haben da viel, minus 10, 10 und da haben wir minus 1, 1 gehabt. Hat er gehabt. Ja, es geht so auch. Okay.
This. So, okay, so the first thing we have to understand is that this angle over here.
Ach Gott, diese fucking Bots.
Is useless, right? With the throttle code, it doesn't matter if the turn is left or right. We only want to know the angle, not the angle. Yeah, we want to know the angle of the turn. We don't want to know if it's going left or right. We want to know how big the turn is. So this minus ranges are pretty much useless. So what we can do is we can drag off this return value z and type in absolute float. We can select that. What this does is this removes.
So, jetzt bin ich aus dem Konzept gekommen. Okay, Moment.
We only want to know the angle, not the angle. Yeah, we want to know the angle of the turn.
Wir müssen jetzt da. Wir können jetzt throttle. Das machen wir da genauso. 1, 1, genau.
We don't want to know if it's going left or right. We want to know how big the turn is. So this minus ranges are pretty much useless. So what we can do is we can drag off this return value z and type in absolute float. We can select that. What this does is this removes the minus of a float value. So if the turn was a minus, which means it was going left, I believe, then what it would do is it would just make it a positive one. And so we only get the angle of the turn. So we're going to connect that to the ABS, and we're going to connect the ABS, the absolute, into the value, I mean. And the in range we're going to set to 0. and then the in range B, we're going to set the value to 40. So any angle between 0 and 40 is going to affect the outranges. Now the outranges, the bottom one is the fastest you want your car to go, and the outrange B is the slowest you want your car to go. So for the fastest, I find that this car can go 150 quite easily and keep high speed with that, but the lowest I find it able to do turns is 50. Now these values you're going to want to customize based on your needs. You probably want to make these variables on the car themselves so that when you have more different cars, you can easily just customize these settings on the car, and the AI will be able to use different cars' settings. So this is a value you probably want to save directly on the car, but I'm going to save time by not making it a variable on the car. But these are the values I find works pretty well. Now the return node, this shouldn't send out a steering input, so we're just going to go click on this return node. We're going to change the output from steering input to top speed. So actually, yeah, no. This, I think let's remove the output over here. So what we want to do is we want to calculate the top speed with this. So this is the top speed. So what we want to do is we want to get the car's current speed, and with that we want to determine, oh, is the car going too fast or too slow? So this is the speed we need our car to go. So this, I think I should go ahead and go to the bottom left under functions, click on calculate throttle brake. I think it should be more fitting if we rename this to calculate top speed so that we know, oh yeah, this is the top speed. So we're gonna right click, rename, and calculate rename this to calculate top speed should be a fitting name. And then we're going to go to our return node, add an output, make it a type float, and we're going to call this top speed. So this is the top speed we should be going. This is the speed we're aiming to go. We can plug in the return value. Now this, we are going to rename this comment block over here because it says convert angle into steering input. No, we're going to just go ahead, double click on that, and change it convert angle into top speed. Okay, we're going to widen this block over here, move the return node, and try to get the absolute node in here. Something like this is perfect, and this is sorted. I'm going to compile and save. Now we're going to go back onto our event graph, and then we're going to remove our set throttle code here. So, did Unreal Engine crash just now? Wait, what? Oh no, it just it just slowed down. I was scared there for a second. Okay, and I fixed Unreal Engine. I was kind of scared it was gonna crash there, but it is totally fine. So what we're going to do is we're gonna drag in our calculate top speed over here, connect that to this set steering. So the set steering connects to the calculate top speed, and this is the
calculate steering.
Set steering. So the set steering connects to the calculate top speed. And this is the top speed we should be going. So what we need to do is now we need to take this top speed and calculate the throttle / brake input. So to do that, we're going to go ahead, go to the bottom left under functions, create a new function, and this one's going to be called calculate.
Moment kurz, meine Katze nervt. So, weiter geht's.
This
So,
one's
er
going
macht
to
eine
be-
neue
To do
Function.
that, we're going to go ahead, go to the bottom left under functions, create a new function, and this one's going to be called calculate. This one's going to be the calculate throttle slash brake. So this code will be the code that actually determines how much throttle or brake we should be using. Okay, so what we're going to do is we're going to add input, and this input is going to be of type float, and this is going to be top speed. Let me just capitalize that correctly. Okay, so this is the top speed we should be going. Now what we want to do is we want to get the current speed of the car and compare that to make sure, okay, this car is going faster than top speed, we should make it brake. If it's going slower than top speed, we should speed it up. Now the problem is that we have no way of getting the current speed of the car. So we are going to change our blueprint interface, which gets information from the car, to add a function that will get the current top speed of the car, or the current, speed of the car. So to do that, we're going to open up our content browser. We're going to go to BPI is vehicle and double click to open it up. We're going to add a new function over here. We're going to call this get
Was hat er denn da noch drin? Get
current speed. So this will get the current speed. We're going to add an output.
Get current speed. Get front of car. Katzi, geh mal in Frieden. Was ist denn? Okay, her. Oh? So, du Nervtüte. Jetzt liegt's auf meiner Maus. Ha? Kannst du mir Ruhe geben? Ich muss da was machen. Get current speed. Er hat dann auch get front of car. Das habe ich aber. Wow. Oha. So. Habe ich Get Front of Car verpasst oder? Er hat aber nie die AI-Path offen gehabt. Oder? Nein. Get current speed.
And yeah, that should be good enough.
So, das heißt Function get current speed ist mit dem Input oder es hat einen Output. Current speed. Mizi. current speed. And it's a float.
We can compile and save.
So, die Musik nervt.
Then what we're going to do is we're going to open up our content browser, go to our content folder, vehicle template, blueprints, and open this vehicle advanced pawn. And then what we want to do is we're going to go on the bottom left. Under interfaces, we're going to open it up, and then we're going to open the set the get current speed. We want to double click and open it up, and this is where we're going to output our current speed. So
Get
how do
front
we
of
actually
car.
get the current speed? So do that. To go on the bottom.
Hat er das schon gemacht vorhin? Das hat er nicht gemacht. Ich hoffe, das erwähnt er noch.
Bottom left, under interfaces, we're going to open it up, and then we're going to open the set. The get current.
Ich verstehe schon. Get current speed.
Current speed. We want to double click and open it up, and this is where we're going to output our current speed. So how do we actually get the current speed?
Get
to do
vehicle
that, we
movement
right-click
component.
and get forward speed. Now there's going to be two options: get
Get
forward speed and get
forward
forward speed miles per hour. Now what I prefer to do is use get forward speed, so like this, and then what I like to do is I like to drag off this return value, do a multiply, and then I multiply this value with 0.036. Now what this does is converts this get forward speed into kilometers, which is just easier for me to work with. We can have a fight about what
One moment, what?
will get forward speed miles per hour. Now what I prefer to do is use get forward speed, so like this, and then what I like to do is I like to drag off this return value, do a multiply, and then now what I prefer to do is use get forward speed, so
Get forward speed. Get forward speed miles per hour. Und dann wandelt das trotzdem mal 0,036 um? Okay.
like this, and then what I like to do is I like to drag off this return value, do a multiply, and then I multiply this value with 0.036. Now what this does is converts this get forward speed into kilometers, which is just easier for me to work with. We can have a fight about what metric system you like to use, but I just like kilometers per hour, so I'm going to be using that. You can also just use the miles per hour one if that suits you better. But anyway, with that out of the way, let's go ahead and connect this to the current speed. Let's just move this return node. We're going to move this code over here. Just move this in here. Go to select all three of these nodes, press C to comment, and we're going to call this get current vehicle speed in kilos. I think I'm just going to use kilos because I feel like it today. But anyway, this is our top speed code, or this is the speed of our current car. We're going to compile and save, close down our vehicle because we're not going to need it. And now all we have to do is we have to compare the top speed with the current speed.
So, calculate, jetzt sind wir wieder in der Vehicle AI.
Of the vehicle. So we're going to go ahead and in the bottom left under variables, we're going to drag in our controlled vehicle. Then we're going to get our controlled vehicle. We're going to drag off this and do get current speed message. And now I'm going to just go ahead and move that over here, plug it into the calculate throttle and brake. And this is our current speed. So this is the speed we are going. So what we do is if the current speed is smaller than the top speed we should be going, we're going to throttle. If the current speed is bigger, that means we need to brake to actually get this, to actually make it slower to fit the top speed. So to do that, we're going to drag off the current speed, and we're going to do a bigger or a greater or equal. Actually, yeah, let's do a greater and equal. And then what we're going to do is we're going to find out if the current speed is higher than the top speed we should be going. So because this is an input to the function, what we can do is we can right click and do type in top speed, and we can use this variable get top speed, and that is this variable over here. We can connect that. So if this top speed, or if the current speed is bigger than top speed, we should be braking right now. So let's go ahead and code that. We're going to drag off this execution node. We're going to type in branch for a branch node. You can actually hold B on your keyboard and left click to shortcut that. But anyway, we're going to drag this greater or equal into the condition. So if this is true, if the current speed is higher than the top speed, we should be braking. Now, if I'm correct, if we open up the content browser and we go back to our AI folder and open the BPI is vehicle, we have the set throttle, set brake, and set steering. Okay, now we're totally fine. Okay, so now how is this going to work? Okay, now with this vehicle, we have the set throttle, set brake, and set into work. Now how this is going to work is we're going to output a throttle and a brake value. So what we're going to do is we're going to go to click on this calculate throttle brake. We're going to go to the bottom right and add two outputs. One is going to be throttle. Why can't I spell now? I mean, I spelled this so many times. Anyway, this one's going to be throttle. The second one's going to be
Brake is a boolean.
This is going to be brake. Now, both of these needs to be floats, so just make sure they both are floats. And then all we do is we drag this return node over here. So if it is true, we are currently faster than the speed we should be going. We're going to connect the true value to this return node. What we're going to do is we're going to make the brake 1 and the throttle 0. But if it is false, we're going to copy and paste this return node, connect the false to it, and what we're going to do is we're going to set the throttle to 1 and the brake to 0. So we then throttle because we're going slower, and then we don't brake. So we just switch out these inputs as needed.
Okay,
so we're going
cool.
to compile and save, go back to our event graph, and now we have the calculate top speed. We're going to go to the bottom left and drag in the calculate throttle and brake value, plug that into the execution pin, plug in the top speed, and now the throttle and the throttle and brake code. What we're going to do is we're going to set the inputs of the car with these values. So that how we're going to do this? Oh yeah, we're going to go to the bottom left, drag in the controlled vehicle, drag off that, and do a set throttle message. We're going to connect that, connect the throttle to it, and then finally we're going to drag off this controlled vehicle again. We're going to use set brake message. We're going to connect the execution pin, connect the brake value to that. We're just going to just use pins to move it around to make it look a bit cleaner. So yeah, something like this should be enough. Maybe if So something like this should be good enough. So this should work. So let's go ahead and compile and save to see how it works. This sort simulating the game. I'm gonna use selected viewports. So let's see.
This should work, he says. Wow! War schon mal viel schneller und bremsen tut er auch. Aber er kann die Linie nicht ganz halten. Er fährt ständig links, rechts. Moment. Aber warum? Der vordere? Das muss man verstehen. Ah, jetzt geht's, ja. Ja, ich fand beide so links, rechts. Okay. Jetzt bremst er. Okay.
What the car does, you can see it is not really doing a good job. It's overshooting it quite a bit.
Ja, ja,
So
seiner macht
this
dasselbe.
is wiggling a lot. So this is actually to be expected. The reason for it is because those values we set, they aren't actually good. Now I'm going to explain why. Now the reason why they're not good is if I go to the set steering, actually not the set steering, the calculate steering, right? This additional distance would have worked if our car was going 50 kilometers per hour. But the problem is that our car isn't always going to go 50 kilometers per hour. And so the moment our car goes way too quickly, it needs to look ahead more. Else it's
Yes.
going to be stuck in the past. It's not going to get enough information to turn correctly. So this additional distance, we actually need to get the speed of the car to change this value and improve this value. So what we're going to do is, at this calculate steering, we're going to drag this to the left a bit. Then we're going to go ahead and drag to go to the bottom left on the variables. We're going to drag in controlled vehicle and use get controlled vehicle. We're going to go ahead and drag off this and do get current speed. Yes, get current speed. And then we're going to just plug that into the execution pin. And then this current speed, we're going to use this to determine how much additional distance we should be adding. So how are we going to do this? Well, we're going to drag off the current speed. We're going to use a map range clamp. So yeah, and the in range should be 50 because that is the slowest speed we should be going. And then the in range B should be the fastest speed we're going, which is 150. And then the out range, I find the following values work the best. 1000 to look ahead, and 3000 if he is going at 150 kilometers per hour. So if you don't know what's going on, this converts speed.
I know what's going
into,
on.
Distance. So the more speed we have, it converts it into more distance to look ahead. And so we're going to go ahead and plug in this return value. I'm just going to widen this comment block, connect this execution pin up, just widen this comment block again, move the controlled vehicle in, and yeah, this should be enough for now. And let's go ahead and compile and save. And just like we had to do this for the turning,
Die
we
fahren schon
also
echt
need
gut.
to do this for the throttle code so that we know, okay, if we're going quicker, we need to see more of the track. So let's go to our calculate top speed. We're going to move our calculate top speed to the left a bit. Then we're going to go to the bottom left, drag in our controlled vehicle, use get, drag off of that, and
Calculate Subspeeds müssen wir auch noch machen. Calculate Subspeed.
to go to the bottom left, drag in our controlled vehicle, use get, drag off of that, and do the current, and use get current speed, right? We're going to connect this execution pin up, and just like last time, we're going to drag off from this current speed. We're going to use a map range clamped. We're going to set the A value to 50 and 150 because those are the speeds we calculated over here. And then the outrange A, I find that this value should be 3 times the turning code with the specific car. So what I do is I set the outrange A to 3000 and then 9000, and this provides the best settings for these cars. What I would prefer you do is you, of course, just like we use the get current speed, you probably want to make these values variables for your car so that if your car has different handling, each car will have different handling. This means that this will actually get this value from the car, and so all the cars will be able to handle correctly if you actually assign good handling information to them. But with that out of the way, let's drag this return value into the additional distance, widen this comment block again, maybe move this a bit to the left, and then finally we're going to drag this get current speed into the get front of car. And now we change the additional distance based on the speed of a car. So let's compile and save. Let's see how this works. Press play. You can see, okay, I'm just going to press F8. That's going to make it easier. You can see he is going slower around the turns, but he's speeding up at the straights. Then he's starting to brake again so that he handles the turns better. Then he throttles and brakes. And he's doing a pretty good job, actually. He might be taking the turns a bit too close for my liking, but this should be easy to fix with just a few number changes. But you can see, okay, it's doing the turn. It's braking into the turn, then it's going to brake in here because this is a wide turn. Then it's going to use hyperspeed in the straight, do this turn over here, and then hyperspeed in the straight. Now, what I like about this is that if I play this again and we go spectate this car again, what I like is it goes slow into the corner and then it speeds up near the end, so that it creates this nice gradual speed up, which is really good looking. And of course, there is no brake light so that you can actually see how its braking behaviors work. But in the next episode, I'll explain how to give the AI a better brake light. So I'll explain how to make sure this AI actually uses a brake light. Yeah, this is pretty good for now. What I would suggest you do is change around these values, find out values that works well for you.
Die wirken well, die wirken well.
Where we do the convert angle into top speed. You can maybe try raising the top speed that the car should these values to make it better. Really good set.
Okay. Brake lights. Brauche ich brake lights?
In this tutorial, we'll smooth out the braking of the AI as well as add the ability for the AI to use its brake lights. So without further ado, let's get into the video. Okay, so before we implement the brake light to our AI car, we actually want to improve the braking because currently it's way too aggressive. Well, that's totally fine if we're going double the intended.
Okay, ich baue keine Lichter ein, aber ich improve das Braking.
Brake 100%. So I want to smooth out the braking on those smaller values so that we have better braking around the corner. The bonus is that it will also improve the brake lights overall, so it's a 2-for-1 special really. So without further ado, let's go ahead and improve the braking first and then add the brake lights. So to do that, we're going to open up our content browser, and once you're in the content folder, you want to go to the AI folder, and once we're here, we want to open up this AIC_vehicle AI, and once we're here, we want to open up the function where we calculate the braking that was in the calculate throttle/brake. So under my blueprint, under functions, we want to double click and open up calculate throttle/brake. And now that we're here, we want to go ahead and smooth out the brake. So how are we going to smooth out the brake? Well, my idea is we're going to use a map range clamp. And the idea is that if we're just a small bit above the top speed, we smooth out between 0 and 1. So we do kind of a low where we check, okay, if we're just a small bit above the top speed, let's just do a small brake value. But if we're way above the top speed, we do aggressive brake, and we're going to be doing that with a map range clamp. Now, if it sounds really confusing, it's going to be way more understandable once we actually code it in. So let's go ahead and do that. What I'm going to do is here in the open, I'm going to right click and we're going to type in map range clamped. And we're going to use the clamped one, not the unclamped one. We're going to left click on that, and here we have the map range clamp. Now the next thing we're going to do is the value here. We're going to connect the current speed of the get current speed function. We're going to connect that current speed into here. Then the in range A should be the top speed. So we're going to right click over here and search for top speed. There's going to be a calculate top speed and a get top speed. We want to use the get top speed. We're going to connect that into the in range A. And then finally, we're going to add the top speed to in range B. But before we do that, we need to add an extra bit of value. So what we're going to do, we're going to drag off this top speed and type in plus on our keyboard and then use the add operator. We're going to click on that. And then finally, we're going to connect that to the in range B. We're going to set this value to 5. And the idea is, before I explain it, the outrange B is going to be 1. And now I can explain it. So the idea is, right, that if our current speed is equal to the top speed, we apply no braking. If let's, for example, say our current speed is 1 kilometer above the top speed, then we apply 0.2 braking because it smooths between 0 and 1 based on that small area. If we are above top speed plus 5, we apply brake 100%. There's no smoothing. There's only smoothing when we have like a little above the current. Our current speed's a little above the top speed. Then we apply smoothing. And yeah, this will help smooth out the brake. One more thing we can do to help this even more is in real life, if you let go of the throttle and the brake, the car naturally slows down. And this is called freeing your car. And we can implement something like that really easily here. So what I'm going to do is I'm going to drag off this top speed and do a plus again. And then we're going to click on add to add a new add node. And then we're going to set this value to 1 and plug that into the in range A. So the idea behind this is that if we're, for example, our current speed is above the top speed, but under top speed plus 1,
Genau.
we just let go of the brake and then naturally let the car slow down. So we free the car, and that will help with really small adjustments to the brake, and will just look smoother around the turns, which is what we want. Now with that out of the way, let's go ahead and clean this up a bit. So first, this current speed, we're going to convert this in a variable because this node layout is a bit ugly. So we're going to hold Alt on our keyboard and left click between current speed and value. Then we're going to go to the left, select our calculate throttle / brake, and our get current speed and our controlled vehicle. We're going to move that to the side. We're going to drag off our current speed and promote to a local variable. That means that this variable is only available in this function. And we're going to change this to current speed, should be a good name. And we're going to move this up and connect the get current speed's execution pin to the set node. Then finally, we're going to connect this execution pin into the branch node. And this output from current speed, we're going to connect to this greater or equal then. And finally, we're going to move all of this together and move that together, move this a bit up to clean that up. And now we just need to clean up this bit. Oh wait, first we have to connect back up the current speed. So we're going to right click here, type in current speed. So current speed. I'm going to use the get current speed variable over here and connect that into the value. And now we're ready to go. Okay, so to clean this up, we're just going to move this return node over here to the bottom. We're going to select all of these, move it a bit up, move this return node a bit to the right. We're going to move this up here, move this a bit here, move this a bit here, move this a bit here. Yeah, this is fine. And we're going to connect this into the brake. And finally, let's just move this up a bit. We're going to select all of these nodes over here, press C to comment, and we'll call this code smooth brake based on current speed. So yeah, that is descriptive enough, I think. Let's just move this a bit to the right. And yeah, this is set up. We're going to move this return node back to where it was. And finally, we're going to double click on this line connecting from false to this return node so that we create a reroute node. We're going to move this down here, maybe a bit to the right. Maybe move this comment block as well a bit to the right. Just this. And yeah, now this is cleaned up and it looks neat and is pretty self-explanatory. Now, one important thing, this you can store on the AI car, so every car can have its...
brake based on current speed. Smooth brake based on current speed.
own own values, and that would be better for a completed final game so that you can control the braking values for each car. But for this tutorial, I'm not going to explain or go over that because it's just going to waste a lot of time, which we can use for just showing the AI, just like I just wasted time over there explaining that. Anyway, now with that out of the way, let's go ahead and implement the brake light. Now, before we can implement the brake light, just like we had to do for the throttle and the brake, we actually need to update our blueprint interface for our car to be able to have a function where we can set the brake light. So to do that, we're going to open up our content browser. We're going to open up the BPI_is vehicle. We're going to top left and we're going to add a new function. This function we're going to call set brake light. I'm going to press enter to save that. We're going to add a boolean input because that's how you control a brake light. So in the bottom right under inputs, we're going to click on add, then it creates a boolean for us, which is good. We're going to rename this to brake light.
Testing a brake light
Up to
again.
first person, and we'll see the AI brakes, and then the light turns on, and yeah, perfectly working, perfectly fine. Let's see now.
Brake lights.
And it goes. Brake
Bug
lights.
that will be
I'm
fixed.
just really dragging this out, but I know of a bug where if the AI car is going around the track and it goes to the beginning of the track, then it for some reason just swerves and brakes. I know about this. In the next tutorial, I will fix it, and that tutorial is going to release tomorrow at the same time this tutorial releases, so just look out for that. It's going to be a really small video explaining why the bug happens and just overall fixing it. So yeah, that's it for this tutorial, guys. Thanks for watching. If you like the content, please subscribe, hit like if you liked the video, hit dislike if you didn't, and I'll see you guys in the next one. Good night, everybody. In this
So, was hat er jetzt nochmal gesagt zum Schluss?
tutorial, we'll smooth out the braking of the goes to the beginning of the track, then it for some reason just swerves and brakes. I know about this. In the next tutorial, I will fix it. And that tutorial, before I go, sorry, I'm just really dragging this out, but I know of a bug where if the AI car is going around the track and it goes to the beginning of the track, then it for some reason just swerves and brakes. I know about this. In the next tutorial, I will fix it. And that's
Okay, das Problem habe ich bei mir vorhin gehabt. Hallo Romino. Das Problem habe ich bei mir vorhin gehabt, dass er da bremst.
Is going to release tomorrow at the same time this tutorial releases, so just look out for that. It's going to be a really small video explaining why the bug happens and just overall fixing it. So yeah, that's it for this. In this tutorial.
So, jetzt machen wir dann gleich das. Ich gehe noch kurz aufs Klo. So, da. Tutorial Nummer 5. Was fixt er denn da?
We will fix a simple bug where the AI would randomly brake at the end of the track for no reason. So without further ado, let's get into the video. Okay, so before we go ahead and actually fix the bug, let's go ahead and take a look at the bug in action. So if I go ahead and press play now, you can see the AI car drives in front of me, drives, and then randomly brakes, and then drives again. Now it's totally fine that he brakes over here because this is a turn, but for some reason he brakes in the straight. He doesn't do this anywhere else, only in the straight, and that's to do with this over here. This is where the track loops, and that is where this error is. So let's go ahead and go fix it. I'll explain more about it once we actually get to the code. But where is that code? Well, if we open up our content browser, and if you're in the content folder, you want to go to the AI folder, and then open up the BP_AI path, and then you want to go to the get closest location to AI
BP path, done.
function under my blueprint, and here is our problem. So, for us to calculate our steering, we add an additional distance above the distance we are along the spline, and then we get the location of that and feed that to the AI car. But there's one problem, right? The spline has a limited length, and so at one point when we get the distance of the distance we are along the spline, and we added an additional distance to that, we are going to go over the length limit of the spline, and this causes a lot of problems. So all we need to do is we need some way to check when we are going over the length of the spline with the additional distance, and then we just need to make sure it doesn't happen. Now, how are we going to do that? Well, we're going to do that by first getting the length of the spline. So to do that, we're going to go to top left. Under components, we're going to drag in our spline. We're going to drag off of that, and we're going to type in get length. And there's going to be two options, but we want to use the get spline length. And now we know how long the spline is. Now we're also going to drag off this return value and type in greater than. So we're going to use the greater operator over here. We're going to disconnect its connection and connect this return value to the bottom, and then connect this plus result over here in the top. So the idea is that if our additional distance plus the distance we are along the spline is bigger than the total length of the spline, we should run code. Now, what code should we run? Well, in this case, we only have two possibilities. We have for this to go over the limit and not go over the limit. So in this case, we can use a select float to clean up this code. So we're going to drag off this boolean. We're going to type in select float. We're going to use that option over here. And so what happens is if this total distance along spline is greater than, then that means it will pick A. If it isn't, it will pick B. Now we can go ahead and plug this return value into the distance, and we can just move this code over here but to the right to create space. Okay, so let's say the get distance along spline and this additional distance is bigger. What should we do? Well, in that case, all we need to do is we need to take this calculation we did here and then drag off of that and do a subtract. So we're going to type in subtract and use that. And now all we have to do is we need to subtract the total length of the spline from this additional length or additional distance, and that will give us a correct length that doesn't overflow the limit. So in this case, I'm going to select the spline and get spline length. I'm going to press Ctrl copy and Ctrl paste to paste that in, and then I'm going to subtract that over there and connect that into the A value. If there isn't an overflow, this means that this calculation is valid, and we can just output it over there. Now we can go ahead and clean up our code. So I'm going to move the select float a bit here, and move this over here. This over here should be good. Actually, I think let's just move this a bit away, move this a bit lower. Then this code over here, we're going to move it closer to the bottom. Move this a bit down. Okay, and this we're going to just move a bit to the side, move this there. And this code here can be a bit confusing to read, so I'm just going to comment this. So I'm going to select all of these nodes over here, specifically these, press C to comment, and I'm going to call this stop additional distance from going over total length of spline. And yeah, that's descriptive enough. This one I'm going to move a bit out, move the spline out as well, move this a bit upper, make sure it makes a straight line, move this a bit down, move this a bit up. Most of this video is actually just rearranging this comment block currently. Anyway, you just move this out. And yeah, this is a bit more readable, still a bit messy, but a lot more readable than it was. Let's go ahead and test our code. So we're going
So,
to
das war's
compile,
schon.
save, hit play, and let's see if the bug happens. He goes in the straight, and he doesn't break early anymore. He only breaks at the turn. That could have been a fluke, so let's go ahead and press play to see again. And he just drives, doesn't break early, only breaks when needed. So that's good. We fixed the bug, we fixed all the issues with this currently. And yeah, that's it for this tutorial. In the next episode, we'll go ahead and do the actual 2-lane system.
Das
And
Video
so
dauert eine
this car has the
Stunde.
advantage because it has the
Das wird jetzt länger dauern. So. Ich hol mir noch was zu knabbern. Bin gleich wieder da. So, let's do that.
in the lane. So you can see it is going good there, but now it's going to, of course, have the disadvantage because of being out of lane. But overtake did happen there. It noticed there was a car in front of it, and thus wanted to overtake to fix that. And yeah, as you can see, we have overtake in collision avoidance. The car avoided crashing into
Okay, cool.
each other because it was
Kannst du mir ein AI-Fahrzeug machen? Kannst du mir ein ChatGPT-Fahrzeug machen? Das schneller ist als alles andere?
checking the car in front of its speed and was working around that. So yeah, we have working collision avoidance and working.
Es gibt jetzt so Fahrzeuge, die auch irgendeinen Algorithmus folgen. Aber das sieht bei Weitem nicht so gut aus wie hier. Die fahren ständig nur auf ihrer Spur und es ist halt für Traffic vermutlich geeigneter.
Overtaking code. You can also see if I hit play, for example, now, go with my car. Let me just try to get in front of these people. Let's get in front of this row. You can see now he swerved out just to get out of my way, so they won't crash into me as well. So now they also have collision avoidance with me because I'm the same as the AI cars. So yeah,
Okay.
that's pretty good. Now it might have not been a speedy overtake, but
Okay,
right side.
wir waren da noch
In this
nicht.
final tutorial, we will add collision avoidance for our AI, as well as add the ability to overtake. So without further ado, let's get into the video. Okay, so the first thing we're going to do is implement the double lane system, because before we can implement the overtaking and collision avoidance, we need the AI car to be able to use more of the track. So we're going to implement the double lane system first. Now, where do we implement this double lane system code? Well, where we should implement it is where we get the location for the AI to drive, and that is currently in the path blueprint. So let's go ahead and open up the path blueprint. To do that, we're going to open up our content browser, and if you're on the content folder, you want to go to the AI folder, and then we want to open up the BP_AI path blueprint over here. And once it's open, you want to go to the get closest location to AI path function. And once you're here, you want to go to this right side where we do the get location at distance along spline. So how do we allow the AI car to drive in this two-lane system? How do we offset where the AI car drives to, well, you know, make them drive at two separate sides of the road? Now, what we'll do is we'll use a get right vector. So the idea is that we want to add a right vector to this return value, and then we multiply that right vector with a value based on if we're on the left side or the right side of the road. So to that, let's go ahead and do that. We're going to drag off the select float, and then we're going to type in get right vector, and we're going to use the get
Get
right vector
what?
at distance along spline.
Right.
We're going to move this up a bit.
Get
And then
right
the coordinate
vector at
space you want to
distance
set
along
to world
spline.
because we want to use world location. And what we want to do is we want to drag off this return value and do a plus or an add operator. And we want to drag this return value into this add operator. Actually, no, we don't want to do this. What we want to do is we want to manipulate this value. And to do that, we're going to drag off this return value and do a multiply. So we're going to use the multiply operator. And now we'll go ahead and connect this into the plus and then connect this into the location to steer to. So what multiplication should we do here? What should we calculate here for this to work? Well, what we need is we need to know what side of the road the AI car is driving on. Now, there's multiple ways to store that, but the best way I found is to store that information in the AI car itself, and then when you're calling this function, to feed it into the path. So what we need to do is we need to add an input to this get closest location to AI path, and then plug that into here. So to do that, we're going to open up our content browser, and then we're going to open up the BPI_is AI path. We're going to click on the get closest location to AI path, and then we're going to go ahead and add a new input. We're going to set the type from Boolean to integer, we're going to call this side of road. And let me just go ahead and compile and save, and we can close that down. We don't need that anymore. And how is this going to work? Well, first, let's right click and type in get side of road. We're going to use this. And how this is going to work is if the side of road is 0, that means we're on the left side of the road. And if the side of road is on the right side, that means, it's for example 1, that means we're on the right side. So how do we use this numbers? So how do we convert the 0 and 1 into a usable multiplication or usable calculation for this? Well, what we can do is we can right click and type in select float. And what you should see is there's an A input and a B input and then a Boolean input. But as you can see, there's no integer input. So how is this going to work? Well, the idea is that the side of road is going to feed into this Boolean value. Now, if you didn't know, integers can be converted into Booleans. The idea is that if that means then we're on the right side, A is picked. If we're on the left side and this is 0, B is picked. Let's go ahead and plug this return value into that multiplication. And then finally, these values, what should we set them to? Well, this is based on your current track. So let me show you how to calculate that values for your current track. So to do that, you want to go to your vehicle example map. And here at this path, so we want to find with the path start, want to select it. And then in the bottom right or under the details panel, you want to click on the spline component itself. Then you want to scroll down all the way until you find this value called scale visualization. Just want to tick that on. And now you should see this weird circle fin that doesn't make any sense. But the idea is that these two lines at the side is where the AI car intends to drive in this 2-lane system.
Moment. Machen wir das da. So, machen wir das da. Da haben wir nämlich ein Spline. Und wo ist
the side is sent and find this value called scale visual.
Okay. Data Spline. Und da drin ist Scale Visualization with. Okay.
Visualization. Just want to tick that on. And now you should see this weird circle fin that doesn't make any sense. But the idea is that these two lines at the side is where the AI car intends to drive in this 2-lane system. So if I set this value to, for example, 200, that means that the left side of the road, the left lane is here and the right lane is here. Now, of course, this is way too close for these two sides to be driving on. So what we can do is we can set this value to 500. And now this looks way better. So this is all based on your track. So you just want to adjust this based on what track you have. But 500 seems to work for this track. So I'm going to turn off scale visualization, go back to my BP underscore AI path. And if we are on side of road 1, so that means we're on the right side, we pick A, and that means that we should do 500 in the offset. But if we're on side of road 0, that means we pick B, that means we should be minus 500. The reason for that is because this is right vector, so minus is left and positive is right with this. But yeah, this is set up. If you want, you can get the value of this from your level blueprint, and that would be the best way to handle this. But to save time for this tutorial, I'm not gonna develop that system. But that's the best way to handle that if you're planning to put this in your game. Just get these values from the level blueprint itself. Now, with that out of the way, let's go ahead and clean this up. We're just going to move this return node a bit to the right, and then we're going to select.
Oha, so stark können die nicht lenken. Das schaut schon echt gut aus.
All of this over here, move it to right, select all of this again, press C to comment. We're going to change this comment block to add offset based on side of road, and that should be a good name. Let's move this up a bit. Something like that should be good. This line seems straight, and yeah, this is cleaned up and ready to go. Now we can go ahead and compile and save. And what we should see is if I go to the vehicle example map and hit play, we should see the AI car drive on the left side of the road. And the reason for this all is because by default, this function is 0. And we need to, of course, set that in the AI car. But that means it is working. If your car is driving on the right side of the road, you should make sure that these values aren't swapped around, because if your car is driving on the right side on that says, just swap these values around, and then it should be fully working. Now, with that out of the way, let's actually, allow our car to drive on more sides of the road, because currently it can only drive on the left side, thanks to us not calculating the side of road. So to do that, we're going to open up our AI controller. So we're going to open up a console browser and open up the AIC underscore vehicle AI. And now what we need to do is we need to add a variable for AI car to say what side of the road it is on. So in the bottom left under variables, we're going to add a new variable. This is going to be called side of road. And we're going to change this from Boolean to integer. And that is good enough. We can compile and save. Now let's go ahead and set the side of road to 1, just to test. Let's compile, save, hit play, and let's see. Okay, our car drives on the left side of the road. The reason for that is even though we set the side of road to 1, we didn't send it for the function, because if I open up the calculate steering function, you can see the get closest location to AI path. The side of road is not connected to our variable. So in every function that uses that function to find the location to drive to, we need to go ahead and plug in our side of road. So let's go ahead and do that. We're going to go to calculate steering first, drag in the side of road here, move it down a bit, move both of these up a bit, and just move that one down. That's set up. We can compile, save, go back to the event graph, set steering. No, we don't want to do that. We want to open up calculate top speed. Here we use side of road. So we're going to drag in our side of road variable, move that down, move that up a bit, move that down, and we can compile, save, go back to the event graph, move a bit to the right, and let's open up calculate throttle slash brake. And as you can see, we do not use that function. And I don't think we use that function anywhere else. So let's go ahead and compile and save. And first, make sure your side of road is set to 1. And if we hit play now, our car should be driving on the right side of the road. And as you can see, it works.
So, schauen wir, ob das geht. Aber jo, es geht. Ganz rechts. Und wenn ich das jetzt auf Null stelle, fahren Sie dann links. Da müssten Sie links fahren. Ah, genau. Geht. Good.
works. So that means our code is fully working and ready to go. Now finally, let's go ahead and do the final thing for the 2-lane road. Let's drag this one a bit closer to the start, so over here, and let's hold Alt on our keyboard and drag away from this car to create a duplicate. And we're going to move that a bit more center. Let's move our player spawn a bit closer to both of these so we can see them. And if we hit play, you can see both of the cars are driving on the right side, and they're probably going to crash into each other, as you can see there. That's not good. So how do we get these AI cars to automatically drive on the side that they start? Now, let's go back to the AIC. And the general idea behind this is that we want to calculate on the begin play what side of the road the AI car is closer to. Now, if you were to create this for your own AI, you know, for a game or something, what I would recommend is in the code where you do the grid system, you can, of course, as you are spawning in cars, designate a side of road. But if you don't have a grid system or just want to get something up and running quickly, I'm going to show you a bit of code, which isn't expensive, but it is definitely overkill for this. Let's move our player spawn a bit closer. Cars are driving, you can see there, drive on. And the general idea behind this is that we want to calculate on the begin play what side of the road the AI car is closer to. Now, if you were to create this for your own AI, you know, for a game or something, what I would recommend is in the code where you do the grid system, you can, of course, as you are spawning in cars, designate a side of road. But if you don't have a grid system or just want to get something up and running quickly, I'm going to show you a bit of code, which isn't expensive, but it is definitely overkill for this. So let's go ahead and take everything in begin play and move it up a bit. Then we're going to, after this AI path, do a new function. So in the bottom left under my blueprint, let's go ahead and add a new function. We're going to call this function calculate starting side of road, and that should be good enough. It doesn't have any inputs, but let's go ahead and add a new output. It's going to be, of course, type of integer, and then side of road. So how is this function going to work? Now first, let's just move this return node a bit heavily to the side because we're going to need a bit of space. But the general idea is that we want to get the location of the AI car, check how close it is to the left side of the road, check how close it is to the right side of the road, and which one it is closer to, we'll pick that as our starting side of road. So how are we going to implement that code? Well, to do that, we're going to first right click and actually, let's go to the bottom left under variables and drag in our controlled vehicle. We're going to get our controlled vehicle. Then we're going to drag off of this and do get axle location. And this node we're going to use. So this is the location of our AI car. And what we can do is we can go to the bottom left and drag in our AI path, get that, drag off of that, and do the get closest location to AI path. I'm going to use message. I'm going to plug that execution pin over here.
Get closest AI path message.
Then I'm going to plug in the get actor location into the AI location. Additional distance should be set to 0. And then this location to steer to, what we're going to do is we're going to find the distance between these two. And how do we do that? Well, we drag off the location to steer to and type in distance, and we're going to use distance vector. We're going to plug in the get actor location into v2, so vector 2. We're going to drag off of this return value and promote to a local variable. And this local variable is going to be called left side distance. Now, it isn't a requirement to save this to a local variable. It's just going to make the code a bit cleaner. Now, with that out of the way, let's drag in the execution pin over here. And let's select all of this code over here, except this left side distance, and press Ctrl D on our keyboard to duplicate. Wait, let me just select everything again. Control D to duplicate. I'm going to move this to the right side and then connect the set left side distance into that. And then instead of side of road being 0, we set to 1 to be the right side of the road. And then we drag off this distance vector's return value, promote to local variable, and call this right side distance. And we're going to plug the execution pin in. And then finally, we want to find out which side the AI car is closer to. Right side distance. And we're going to plug the execution pin in. And then finally, we want to find out which side the AI car is closer to, so we can output the side of road. So to do that, we're going to drag in the left side distance, get it. We're going to drag in the right side distance variable, get that. And what we can do is if the we're going to drag off the left side distance and do a greater node. We're going to drag the right side distance into the bottom one. And if the left side distance is bigger than the right side distance, that means we are closer to the right side of the road. And now, just like in the AI path where we did this Boolean conversion, we can secretly do it here. And so if the distance on the left side is further away than the right side, that means we are on the right side of the road, or aka 1. So this is going to output 1 if we convert it. So that's going to be correct. So let's drag that into the side of road, drag in the execution pin over here. And then let's go ahead and select everything here. Press C to comment. We're going to call this...
Das was?
Drag in the execution pin over here.
Okay.
And then let's go ahead and select everything here. Press C to comment. We're going to call this get the side of road based on distance from each side. Let's go ahead and compile and save. And then we'll go to the event graph. Go to the bottom left and drag or calculate.
Slow down, brother.
Go to the event graph. Go to the bottom left and drag or calculate starting side of road in. Connect the set AI path into that.
Calculate steering side of the starting side of road.
Then the side of road, we're going to go to the bottom left under variables, drag in the side of road, set side of road, and connect the side of road here. And if we compile, save, and hit play, you should see both AI cars drive on the side.
Oha. Oha. Überholen. Ist knapp. Okay, cool.
They should be driving, and yeah, that's good. So let's go ahead and increase the car count. So we're going to click on this one here, hold Alt and drag in one in the front, hold Alt again and drag one to the left. Let's hit play and let's see if it works. As you can see, they all are driving on the side they should be, but you can also see that they're eerily close to each other and so can possibly crash into each other. And the reason for that is because they don't have any form of collision avoidance or anything of that sort to actually avoid each other. So now in the next part of this tutorial, which is happening now, by the way, there's no next part of this, but in this next part of the tutorial, we're going to implement collision avoidance. Also, we're going to implement overtaking code based on the collision avoidance and all that. So let's go ahead and start with that. Now, the general idea for this is we're going to be using triggers. So we're going to add boxes around the AI cars, and based on what cars in the AI box, it will react differently. Now, there's There's a lot of ways you
So,
can do
das
this. You can do this with raycast. You can also use the
zappen wir nochmal
spot.
durch. Das ist Collision Avoidance. And possible improvements. So, wie schaut's jetzt aus?
Tutorial series. I gave a few pointers on how to improve the overtaking. Of course, using wider like turn distances out of my way, so they won't crash into me as well. So now they also have collision avoidance with me because I'm the same as the AI cars. So yeah, that's pretty good. Now it might have not been a speedy overtake, but some things you can do is something you can do that I think would work really well, and I've tested it previously. But something you can do is that when your car is overtaking, you can add an additional speed boost to the car temporarily. So let's, for example, say for 3 seconds our car has a...
Okay.
There's a lot of ways you could do this. You can do this with raycast. You can also use the spline as a way to get information. But while those systems can work better than a box system, and I kind of do prefer them, they can get very complex very quickly. And it's just going to be a very, very, very long tutorial if we were going to use those. So we're just going to use boxes for that. So let's go ahead and add collision boxes to our AI car. So we're going to open up our content browser and we're going to go to our content folder, vehicle template, blueprints. We're going to go to the vehicle advanced pawn, and then we're going to go to the viewport. I'm going to zoom out a bit. And let's go ahead and add boxes to our AI car. So we're going to go ahead, add a new component.
Okay, Moment. So, das kann ich hier nicht machen. Ich brauche das Advanced Vehicle und dann brauchen wir da noch Komponenten.
This is going to be box collision. We're going to call this front box. I'm going to move it into the front. We're going to go ahead and resize it. So I'm going to press R on my keyboard to scale. I'm going to scale this up. Let's just put it in front of the car still. Scale it up a bit, move it up a bit, scaled a bit wider. And now any car that is in this box, the AI is going to detect. And now based on that information, we can do stuff. Now that is good for collision avoidance because what we can do now is we can know, okay, there's a car in front. Maybe I should slow down if I'm really close to him. But this isn't good for overtaking because, well, we have no information of the cars next to us. So what we're going to do is we're going to go ahead and add boxes for each side of the car to determine overtaking for each side. So we're going to go ahead and add under components a new box collision. So box collision, going to add a new one. This one's going to be called left side box. And of course, we're going to move it to the left side of the car. Let's scale it up. And this one you should scale pretty widely because based on how wide your track is, you want to get as much of the right side as you can. But it's also very important to note that if you make this too wide and your track is very close to each other, then maybe the car will detect a person on another turn as in its way, and then it's going to be quite funky. So try to make this as big as possible, but if it causes problems, just scale it down a bit. Anyway, I'm going to make it this big. I'm going to resize it over here. And the reason for resizing it this way, or as big as it is now,
So
the reason for
groß.
this is that if a car is, building up speed, and we try to swap into the lane, then the problem is that we're going to maybe swap into the lane too slowly, and this car that is coming along here is going to crash. So we want to make this car make sure that there isn't a car approaching at a rapid speed. Now, you can scale this box down based on how aggressive you want the AI to overtake, but for now I just don't want a too aggressive overtake, and so I'm going to set this value to this, going to scale it up, and then finally we're going to add a box just like this, but for the right side. So we're going to right click on the left side box, we're going to duplicate, we're going to call this right side box. Now that we have that, let's go ahead and move that to the right side, just about the same position. That should be good enough. Let's go ahead and drag this onto the mesh so that you know they aren't over each other. The front box, I think, should be above. Oh, well, I can't really set the sorting of that, so this is good enough. But let's go ahead and compile and save. Let's see if it works. So as you can see, it kind of isn't fully touching this car, so it's not really going to work well. So let's go ahead and just make the both side boxes just a bit larger. So something like 14, move them up a bit. Select this one, make it something like 14, move it a bit to the left. And let's compile and save, and let's see if it works now. As you can see, it now sees more of that car, so it's going to work now. Maybe I think I'm going to go ahead and improve this front box because it is really small. So something like this should be good enough. Just make sure that it's a bit in front of the car, because you can have some very wacky behavior if it is touching the car. So just move it a bit in front of the car. But yeah, this should be good enough. So let's go ahead, compile and save. If we go to our vehicle example map, as you can see, the boxes are touching the other cars in the other lane, so this is going to work perfectly for this. Now finally, at least for this, is that if we go to the vehicle advanced point, so it's something like this, should be good enough. Just make sure that it's a bit in front of the car, because you can have some very wacky behavior if it is touching the car. So just move it a bit in front of the car. But yeah, this should be good enough. So let's go ahead, compile and save. If we go to our vehicle example map, as you can see, the boxes are touching the other cars in the other lane. So this is going to work perfectly for this. Now finally, at least for this, is that if we go to the vehicle advanced pawn, then we actually have a problem, right? So all of these boxes actually count as part of the vehicle. So if we go to the vehicle example map, and for example, look at this box over here, then this box is going to count as a part of this car. And so this car is going to detect that there is someone in front of him and someone to the left of him, and thus be very slow, even though, well, there isn't any car in front of him. So we need some way to make these boxes not register as parts of the car. And for that, we're going to set custom collision information for these. So if you click on these boxes, you want to go under the details panel, you want to go to search and type in collision. And then you can see here's a few collision presets. We're going to change the collision presets from overlap all dynamic to custom. And the query only should be on, so no physics collision. Object type wall dynamic is correct. We're going to ignore all the collision responses except the vehicle. The vehicle we are going to overlap. And so you want to set that for each one of these boxes. So custom, ignore all, set vehicle to overlap, and make sure that these settings are correct. Click on this box over here. Same thing, custom, query only, wall dynamic, ignore everything except vehicle. And if you compile and save, now these won't count as parts of the vehicle, and so it won't cause any buggy behavior. So if your car is randomly just slowing down for no reason, just make sure that these collision presets are correct. Now with all that out of the way, we can go ahead and actually create the collision avoidance and overtaking system. So to do that, we need some way to feed these boxes to our AI car, to our AI controller. And for that, we're going to use a blueprint interface and feed it that way. So we're going to open up our content browser, go back to the content folder, go to the AI folder, and under BPI, or we're going to open up BPI underscore is vehicle. we're going to go to the top right and for my blueprint, add a new function. This function is going to be called get collision boxes. That should be good enough. We're going to add 3 outputs, output, 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 and then all of these are going to be changed from Boolean to box collision. So we're going to type in box collision. So we want to set all of these to box collision. I'm actually going to delete those, add those because now everything's box collision. Then the first one is going to be front.
So, box collision, box collision, and this is front.
Front box. The next one is going to be left side box. The third one's going to be right side box. Perfect. We can go ahead and compile and save. And we should be done with this for now. Let's go ahead and implement that function into this AI car. So we're going to go to interfaces over here and we're going to open up the get collision boxes function, and then now we're going to open up the get collision boxes interfaces over here into. We should be done with this for now. Let's go ahead and implement that function into this AI car. So we're going to go to interfaces over here.
Get collision boxes.
And we're going to open up the get collision boxes function, and then now we feed the collision boxes in here. To do that, we're going to go to the top left on the components, drag in the front box, connect that to the front box, drag in the left side box, plug that into the left side, drag in the right side box, drag that into the right side box. Let's go ahead and move this over here, move this over here, move this over here, compile and save, and yeah, that's it for now here. And we should be done for the vehicle advanced spawn. But so every car you add, just make sure that when they are based on this vehicle advanced spawn, that you adjust the boxes for each car accordingly so that you know they aren't clipping or anything. That's just a general good rule of thumb. But yeah, we're done for that for now. Let's go ahead and actually.
They shouldn't clipping, okay.
Implement the collision avoidance and the overtake code. Now to do that, we're going to create a function. So we're going to go to the bottom left on
It's a vehicle AI. Event graph.
the functions. We're going to create a new function, and this function is going to be called check for overtakes. So this
What?
function will exclusively check.
Check for what? Check for overtakes. Okay. check for overtakes.
For overtakes or possible crashes and stuff like that, and then react accordingly. And now to, of course, do anything here, we need those boxes to get information from them. So in the bottom left, we're going to drag in the controlled vehicle, get that, and drag off of that, and get collision boxes message. And we're going to plug in the execution pin over here, and that's it there. Okay, and now it is very important to note that thanks to the way we set up our collision, we don't have to cycle through everything here to make sure that they are vehicles or anything, because this is guaranteed to overlap vehicles, and thus will only give us information about vehicles. But we are going to have to adjust the front box. Actually, no, we don't have to worry about that. I was just overthinking this a bit too much. Anyway, what we can do is we can drag off of this front box and get collision. Let's go. Get overlapping actors is the function you want. And so this will check what vehicles and stuff are in front of our car. Now, of course, this can return nothing. So what we're going to do is we're going to drag off the overlapping actors, do a greater than node, and actually, I'm just going to drag off the overlapping actors and type in length and plug that into this greater. And so the idea is that if there is, if this overlapping actor's length is bigger than 0, that means there is a car in front of us. So we need to execute some code. So let's drag off of this and do a branch node. We're going to go ahead and plug this execution pin over here. And let's go ahead and do some code. Now, so for now, what I'm going to do is I'm going to save variables based on this information, because I want to see everything that's around the car before deciding what I want to do. So we're going to drag off of this value and promote it to a local variable. What we're going to call this is car in front. Actually, let's call this vehicle in front question mark. And so if this is true, that means there is a vehicle in front. So let's just plug that into true. And also what we're going to do is we're going to get this overlapping actor and save its actor as a variable. So what we're going to do is we're going to drag off this overlapping actors, get a copy. This is going to
get a copy
to be set to 0. And then we're going to drag off of this, promote to a local variable, and call this car or vehicle in front. So then we have a reference to the actor. And this way that later, if we want, we can check the speed of the car in front of us. And if there is no overtake.
Nochmal, what?
We have a car or vehicle in front. So then we have a reference
in front. Vehicle in front. So
to the actor. And this way that later, if we want, we can check the speed of the car in front of us. And if there is no overtake opportunity, then let's slow down our car to fit the car in front speed. So this is just to get variables from the car later on in cases where we can't overtake them or do anything to be speedier. So let's just drag the set nodes execution pin into that set node. Now, this is all the front code sorted. Let's go ahead and do the side code. So I'm going to select everything over here, move it a bit to the right. And I think let's do a sequence node so it does checks. So we're going to drag off of this. Actually, we're going to hold S on our keyboard, left click to create a sequence node. We're going to drag that execution pin over here. And the first thing in the sequence is we check if we have a vehicle in front. Then we'll go to see if we have a vehicle at the side. But before that, let's drag off this then one. We do a branch node. And then we're going to check first. Let's go get our vehicle in front variable, get that, drag off of that. And we just want to see if this is true. So if vehicle is in front, so we'll just drag that in. If there's a vehicle in front, we can check if there's a car in the side. If there isn't, there is no point to this because there isn't a car in front of us, so we don't have to worry about cars on the side because that means we can just speed up, right? So it's an unnecessary check that we are avoiding by checking if there's a car in front. Now, if there isn't a vehicle in front, we can check if there's an overtake opportunity. So now we can go ahead and copy this code.
Copy this code.
Over here and connect that to the true. But it's important to note that we don't really have to worry about getting the axle because we don't care about the speed of the car next to us. We only care about the speed of the car in front of us for brake control and all of that. But we also have a problem with this vehicle code where we check the car on the side because of course we don't know what side to check. So we need to check different sides based on, of course, what side we are currently on. So let's select all of this code over here, drag it a bit to the side. Let's drag in our side of road variable, get that.
So, wir brauchen eine side of road.
And then what we're going to do, so we're going to drag off of that and do another branch node. So I'm just gonna right click, type in branch. Actually, if you hold B on your keyboard and left click, that also creates that. I just forgot for a second. Drag in the side of road here. So we're going to just move that branch node up here. And so if side of road is 1, aka we're on the right side, that means we should then drag this true node in here. And then the check should be right side box. If this is false, we can select off this code over here, copy paste, and we can drag in the false over here.
So, ich will noch kurz was checken. Was könnte get overlapping actors? Select Class. Okay, da ist er nichts ausgewählt. Okay. Gut, kenne mich aus.
Code over here, copy paste. And we can drag in the false over here. And this value, we're going to just make this left box. And these vehicle in front booleans, we just want to go ahead and delete those. And we want to...
What?
We just want to go ahead and delete those. And we want to, of course, create variables specifically for left and right. So we're going to go ahead and take this vehicle in front, right click, duplicate, and call this vehicle in left side. And then we're going to duplicate that, right click, duplicate, and make that vehicle in right side. So now we know if a vehicle is on the left and right side. So we just need to apply that. Right side, we're going to drag in here, set the vehicle right side, true, plug that value in here.
Wait. Ist das jetzt ein Boolean oder? Okay, das ist ein neues Boolean. Okay. Vehicle in right.
and then vehicle left. Side, drag that, set, tune, plug the boolean over here. And yeah, now we know if there is a car in the left and right side. And now we can thus do code based on that. So finally, we're going to go ahead and add a new pin to the sequence. And now we're going to do code here based on... so this is the place where we're going to do the code where we decide what to do. Now to do this, we're going to drag off this den2 actually. First, let's move all this code to the side because this might get a bit messy. Let's drag off this den2 and we're going to start off with a branch node. And what we want to do is we want to check if a vehicle is in front or bool.
So, slow down, brother. What's happening?
Now to do this, we're going to drag off this den2 actually. First, let's move all this code to the side because this might get a bit messy. Let's drag off this den2 and we're going to start off with a branch node. And what we want to do is we want to check if a vehicle is in front or boolean, or a vehicle is in left side. Actually, no. We want to check.
So, ich mache jetzt dieses OR. Vehicle is in left side. Yeah.
If a vehicle is in left side or right side, so a vehicle is in left side or right side, so and a vehicle is in front, so we're going to drag off of that, do an add, not the add, we're going to drag off of that, type in and use an and boolean. And I'm going way too fast, so let me actually explain what's going on here. So what we want to do is we want to check if a vehicle is in front and if there's a vehicle on the left side. So if there isn't a vehicle in front of us, then this code won't matter. If there isn't a vehicle on the left side, it won't matter. So why are we doing these checks? So the idea is that if a vehicle is in front of us and there's a vehicle on the left side, and that is true, then we want to run code to slow down our car to the speed of the car in front of us. If this is false and there isn't a vehicle in front of us, or there isn't a vehicle on the left side, then we're going to overtake practically, because now we know we can. Now with that out of the way, let's go ahead and write this code. So if it is true there's a vehicle in front and there's a vehicle on the left side, then what we're going to do is we're going to override the speed of our car to match the car in front of us. So while you could technically use these boxes as a guide for it, what I personally do is I check the distance of our current car and check the distance of the AI car, compare them, and then use code specifically to that distance. So to do that, we're going to go to the bottom left, drag in our controlled vehicle, get, drag off of that, and type in get actor
Control vehicle.
location. And then we want to get the location of the
Get
car
actor location.
of us. So we're going to drag in the vehicle in front actor variable, drag off of that and do get actor location. And then we're going to find the distance vector between these two. And then we want to check if this value is greater.
Was steht da in der Mitte? Distance, okay. Distance vector.
So you want to use the greater now. If this value is, for example, greater than 700, then we should match our car speed. Actually, no, this should be less than. So drag off this return value, do a less than, and make sure if this
Gott. Greater is a less than.
value is 700. So if our car if there's a car right next to us, so we can't overtake the car in front, and there's a car in front of us, then based on how far we are from the car, in this case, if we are closer than 700 units, we will limit our car speed to the car in front of us. So that means we will brake our car so that we don't go too fast and crash into the car in front of us because we have no overtake opportunity. So let's go ahead and drag off of this, do a branch node, not a branch node. I don't know why I keep making that same mistake. Anyway, let's drag this true branch into that, and then let's go ahead and run some code here. So for this, all what we're going to do is we're going to have a variable called override top speed, and that's going to be a boolean. And the idea is that in our AI vehicle AI, the code where we calculate top speed will have an override. So if there isn't a car in front of us, we'll follow our get current speed function. If there is a car in front of us and there's a car next to us and we need to slow down.
So, ich muss kurz die Katze rauslassen. Miezi. So. Und ich taue mir mal ein Brötchen auf. So, ich will das noch fertig
So we're
kriegen.
going to override the top speed to the car in front of us. So let's go to the bottom left under my blueprint, add a variable. This variable is going to be called override top speed question mark. I'm going to change this from integer to boolean. We're going to add a new function or new variable.
What override top speed? Question mark. Boolean.
This one's going to be called override top speed. And this one is going to
Wait. Not a local variable. Override top speed, boolean. And then override top speed.
be float because this is the top.
Override top speed. Top speed float.
Speed we want to override to. So we're going to drag in this override top speed, set it, drag that, set this to true because we are very close to the car in front of us and thus we want to slow down to its speed. And then we want to drag in the override top speed, set that. And now we need to get the speed of the car in front of us. So we're going to go ahead, drag in
Das.
in the go to local variables, drag in the vehicle in front local variable, drag off of that and get current speed message. We'll go ahead and connect that up here with the execute.
It's current speed message.
Execution pen, plug in the current speed over here. And now if a car is in front of us and we can't overtake, we'll slow down to the car in front of us speed so that we don't crash into them. So now we have collision avoidance for cars in front of us, so we can reduce the general crashing of our AI car. Now we can go ahead and do some overtaking code. So Where should we do this? Where should be a good place to do this? Okay, and I actually needed to go ahead and open my other project where I actually fully completed this just to check. But what we want to do is off this false value, we want to drag out and do a branch node. I'm gonna type in branch. And the idea is that we want to check if there is a car in front. So we're going to drag in our vehicle in front, plug that into the condition. And so if there is a car in front and on the left side or the right side based on whatever, then we should limit our car's speed to the car in front. But if this is false, and if we have a vehicle in front of us, and this means there isn't a car to the left side of us, because, well, as you can see, this check failed. So that means that we are ready to go. And if this value is true, that means we can overtake and we can swap lanes to do that. If this value is false, then we don't have to overtake because there's not a car in front of us or a car right next to us. Quite a confusing flow of nodes, I understand, but I'm trying my best to explain this. But it can get quite complex, as you can see. But now with that out of the way, let's reiterate. True, that means there is a car in front of us, but there's not a car next to us, so we can overtake. False, there's not anything in front of us or next to us, so it doesn't matter, we can just continue. Anyway, now with that out of the way, what we're going to do is we're going to drag off true. Actually, we're going to go to the bottom left, drag in our side of road, get side of road, and we're going to right click and do a select node, a select integer, so we want to use a select int, and so we're going to plug in the side of road into A. So if side of road is 1, that means that we're on the right side of the road, it will pick A, and thus we need to set the value to 0. If side of road is on 0, that means false, that means it's going to pick a B, and so we need to set the value to 1. Again, bit confusing, but once you get over this confusing boolean to integer thing,
Ja,
it
ich
gets
verstehe
quite
schon.
understandable.
Komm.
But now with that out of the way, we can go ahead and drag in our side of road, set side of road, drag in the return value, and just plug in the true. And then finally, this override top speed, we need to change this variable if there isn't cars
So, jetzt springt er wieder so schnell.
value, and just plug in the true. And then finally, this override top speed, we need to change this variable if there isn't cars in front of us. So let's go ahead and go back to our first sequence. And then here where we do this check for the branch, what we need to do is on false, we need to go ahead and drag in the override top speed and set it. In this false, we want to not override speed because there's not a car in front of us. If this is false, no cars in front of us, and we shouldn't have to override speed. Now, next to this, vehicle in front, override speed. Now, next to this, vehicle in front, if this is false, again, no need to override the top speed. So, set override top speed. Actually, wait. This check is unnecessary because if vehicle in front is not there, this code will not run to begin with. So this branch is useless. You just directly connect this false over here. Sorry that
Oh, this branch is useless. He says.
I messed that one up, but yeah. We connect code will not run to begin with. So this branch is useless. Not there. This code will not run to begin with.
This branch is useless.
So this branch is useless. You just directly connect this false over here. Sorry that I messed that one up, but yeah, we don't need that extra check. This does it for us
So.
automatically.
Katzi! Was los? Kommen Sie. So, jetzt haben wir das.
But anyway, this one, override top speed, should be false. Everything here, let's also override the top speed. Override top speed set here. This one should be false. Override this one, override top speed.
Oh, this one. Alright, top speed. False.
Should be false. Everything here, let's also override the top speed. Override top speed set here. This one should be false. This one should also be false. Override top speed. Anywhere where there is an open execution pin, you want to set override speed top speed to false.
Oh, da unten hat er noch.
As you can see, everything here. And our code is a bit filthy right now. It's not really cleaned up, but let's go ahead and actually test our code. Let's go ahead, compile save, go to our event graph, and actually hook up this fin.
So, Event Graph.
In the event tick, we're going to drag this out, drag in the check for overtakes, connect that up, and connect that up.
Check for overtakes. Mitzi.
And one more thing before I forget. This override top speed and override top speed boolean, the speed and this boolean, we need to actually implement that into our function. So
Hallo Smash, hallo Smash.
let's go to the event graph. Let's go look for where we do the calculate top speed. Go to that.
Hatzi, gib mal Ruhe. Komm. So, ich bin schon fast am Ziel. Ich mache selbstfahrende Fahrzeuge. Ich muss da jetzt noch kurz aufpassen. Ich bin gleich fertig.
Tick, we're going to drag this out, drag in the check for overtakes, connect that up, and connect that up. And one more thing before I forget. This override top speed and override top speed boolean, the speed and this boolean, we need to actually implement that into our function. So let's go to the event graph.
Hatzi, aus.
Let's go look for where we do the calculate top speed. Go to that, and then let's look for the code where this is going to work. Okay, so here we're going to move this calculate top speed. We're going to drag in the override top speed, do a branch node. And so if override top speed is true, let's just go ahead and do that. If this is true, we just need to ignore this code overall and then output the override top speed. So we're going to right click and type in return, add a return node. Then we're going to move our override top speed into here, get override top speed, plug that in there, move our override top speed into here, get override top speed, plug that in there, plug the true into there, plug the false into here. So if override top speed is false, we actually calculate the top speed. If it is true, we just output our new overridden top speed. Let's compile, save, and let's hit play. Let's see what happens. So you can see our AI cars actually drive. As you can see, around the turns, they start braking. What's going on here? Oh no, they're going wacky and there's something wrong with our code. So let me actually go ahead and check to see what is going on here. Okay, so as you can hear in the change of my voice, I've been here for a while and I found out it is a really stupid bug. So the first bug is that here, where we actually check the car's left side and right side, these should be swapped, because if side of road is 1, aka true, you don't want to check the right side, you want to
Okay, Moment.
check car's left side. Is that here, where we actually check the car's left
Check for overtakes. Hier.
side and right
Genau da.
side. These should be swapped, because if side of road is 1, aka true, you don't want to check the right side, you want to check the left side, because you are currently on the right side. So you just want to go ahead and swap these two around. So true should be here, and
Okay,
false
es
should
geht
be
aber
here.
nur die
So let me
getauscht.
just connect that up there, move this a bit closer. And then finally, here where I said that a branch was useless, clearly I misspoke, because that was the most important part of this. So let's drag off of this, do that branch load again, and then finally all we have to do is check if there's a vehicle in front. So let's go to local variables, drag in vehicle in front. So if there is a vehicle in front, let's swap out. If false, what we
So, okay.
can do is we can again set the override top speed. So let's drag in the set override top speed.
Set our top speed of false.
Plug in the false, set override top speed to false. Also, we can set it here to false. It's also a good place to set it to false. Plug that into there.
Auch hier müssen wir es auf false setzen.
Move this up, and this should produce better results. Actually, one thing as well, what you can do is here, this doesn't have to be a branch node. This we can just plug in directly here. And so if this is true, it will call this. And if this is false, it won't call them. So that is a cleanup we did just there. Other than that, another cleanup we can do here is just connect the false in here as well. That is another cleanup. Other than that, we should be ready to go. So let's go ahead, compile, save. Let's see if it worked. So if I press F8, you can see the cars drive. They're driving. Oh, that's good. Oh, he swapped. Oh no, they're doing it again. Okay, and I know why. This wasn't a cleanup.
So, SK hat noch irgendwas gemacht.
This was a
Check for overtake.
screw up, actually, because if this is false, it's also gonna run this, which is gonna run this anyway. So yeah, no, this needs to be separate. Tried to be sleek there with the code cleanup, but I might just ruined everything. Compile, save, and now this should work fine. Code cleanup, but I might just ruined everything. Compile, save, and now this should work finally. Let's see if it works. Hopefully. And as you can see, the car behind them brakes because the car in front of them is slowing down. What you should see is they do this around every corner. So now they avoid crashing into each other. Now here in front should be a prime opportunity for overtake. So this car should now...
Okay. Es geht. Es geht. Oh. Misch mich da einfach ein. Die fahren schon ziemlich gut. Ja, ich will, dass du mir auswächst. Okay.
I'll try to go into the other lane. to overtake. So let's see if he does it. And currently it doesn't seem like he is doing the overtake. So this seems to be a problem with the overtake code. And so I found out the reason why it wasn't really overtaking is because of our previous box sizes. So previously the boxes were too close to the AI car on the left and right side. So it would happen that the AI car would think there's a car at the side, but it's actually the car in front. So
Okay, one moment. Gut, ich verstehe schon. Das muss breiter sein. Sonst denkt er, es ist vor mir. Machen wir das 17. Oha! Das funktioniert schon ganz gut.
all you want to do is just give the right boxes and left boxes a bit more spacing to work with, and also widen the front of the car so that it detects better. Something like this setup should be good enough. And if we hit play now, press F8, you can see our AI car drives around, sees the car in front is braking heavily, and now it's just trying to follow its footsteps. You can see they speed up, brake again. So currently they're collision avoiding. There should be an overtake opportunity happening there, so it does that. This car notices this one swerved in front of him, so he's going to move into that lane. And so now this car has the advantage because it has the inner lane, so you can see it is going good there, but now it's going to, of course, have the disadvantage because of being outer lane. But overtake did happen there. It noticed there was a car in front of it, and thus wanted to overtake to fix that. And yeah, as you can see, we have overtake in collision avoidance, the car avoidance.
So, wir haben alles. Wir haben alles. Wir können jetzt nur noch ein paar Werte anpassen und mal ein paar Bibabo machen. So, ich bin jetzt hungrig. Ich habe genug. Ich werde mir jetzt nochmal den Code vom Blazing Race Template anschauen. Und morgen werde ich weiterbauen. Also entweder baue ich mir selbst in mein Projekt sowas ein, oder ich schaue mir zuerst das Blazing Race Template AI an und schaue, wie ich die verbessern kann. Aber wenn die so fahren wie hier, bin ich schon sehr zufrieden. Jo. So, also gut. Also gut, ja, ich mache jetzt Schluss. Wir sehen uns vermutlich morgen wieder. Ich werde morgen wieder streamen. Ciao, ciao.